Okay, so today we will discuss the October 2021 S2 paper. Okay, so question number 1. Shall we start? This is z to the power of 5 minus 32y equals 0, and they want you to solve it, right? So giving each answer in the form r, e, I, theta, where theta is between 0 and 2 pi. So clearly they have given the theta range. So when you get something like this, what's the first thing we do here? So what's the first thing that we do? We write here, yeah. So we have here z to the power 5 equals to 32i. First thing what we do is we get the modulus and the argument, right? So 32i means 32 comma 0, right? So basically here the r value is 32i. Sorry, 32i means 0 comma, yeah. It's 0 comma 32 because it's 0 plus 32y, right? Real axis and imaginary axis. So 32y is over here. So which basically means your r value of course is directly the 32, right? Yes. And theta is pi over 2. Okay, so we can write here 32y can be written, we can write the complex number z to the power 5. 32y can be written in the modulus argument form. R is, so r cos theta plus I sin theta, the modulus argument form. So basically all you have to do is fill the theta and r. So r will be 32. R is 32 cos pi over 2 plus I sin pi over 2. This is what we get, right? And then, of course, you could name z these r cos theta plus I sin theta, or basically you could move the power 5 to the other side. That's also correct. So z equal to the power 5 goes to the other side, 32 to the power 1 over 5, and cos pi over 2 plus I sin pi over 2 to the power 1 over 5. Right? So then, what's the next thing that we do? Before we multiply the 1 over 5, we add the 2k pi, right? We add the 2k pi because basically we are in De Moivre's theorem when we were learning that. Before that, in this, when we are finding multiple roots for z, we were told that adding the multiples of 2 pi and getting the cos and sine ratios makes no difference, isn't it? So before you put the 1 over 5 inside, okay, 32 of course to the power 1 over 5 is 2. This is going to be cos pi over 2. And if you add multiples of 2 pi, you're not doing any, there's no difference in it, right? So this is the method that we use to find all the possible k values, the z values, all the possible rows. And then the power 1 over 5, we can take it inside by De Moivre's theorem. So according to De Moivre's theorem, the power 1 over 5, you can multiply it with the angle, right? So what do you get here? Pi over 2 into 1 over 5 is pi over 10 plus 2k pi over 5 plus I sin pi over 10 plus 2k pi over 5. Okay, and then what we'll do is we need to input the k values, right? So we need to input k values and get the theta angles between 0 and 2 pi. So this gives us the answers. So R value is found. Okay, so let's put the first k value. K is starting with 0, right? So first when we input k as 0, what do we get? Is that equal to 2 times cos pi over 10, right? Okay, so pi over 10 plus 0. This is I sin pi over 10 plus 0. Is that okay? There are other ways of doing this as well, where you name z as, where you can compare coefficients and do by using z as r cos theta plus I sin theta. Okay, so then, okay, and then, yeah, so then here we have our first theta value and r. They have asked us to give the answer in the form r, e, I theta, right? So what's the first answer for z? Z1 is, the first answer is 2e I times pi over 10. So this is the first answer. So I said. Okay, then let's get the next answer. Let's put k as 1. So when k is 1, what do I get? Is it equal 2 times cos pi over 10 plus 2, k is 1. So when k is 1, you get 2 pi over 5, right? Plus I sine pi over 10 plus 2 pi over 5. Can I know how much is the addition? You already got it, right? Is it equal 2 times pi over 2 plus I sine pi over 2. So basically this gives us the R value and the theta value, REIT. So this is our second solution. Z2 is REI theta. So R is to EI theta. Okay. Next solution. So, we need to go until we satisfy 2 pi, right? And also, because with z to the power 5, we are supposed to get how many answers? We need to get 5 answers. So, next one, when k is 2, what do we get here? Z equals 2 cos pi over 10 plus 4 pi over 5. To how much? Cos 9 pi over 10. Sine 9 pi over 10. So basically the third answer is 2e I 9 pi over 10. The I, of course, you can write in front of that. Then when k is 3, is at 4, the next root 2 times cos pi over 10 plus it's when z is 3, 2 times is 6 pi. How much is it? How much? 13 pi. REI theta. So when k is 4, z equals how much is, shall I directly write the answer? Cos how much is it? When k is 4, pi over 10 plus 8 pi over 5, right? How much is it? 17 pi over 10 plus I sine 17 pi over 10. So we can write immediately, which is what? Z5 is REI theta. So that's it. I think if we take k equals 5, you will automatically realize it will jump 2 pi. Now these are all in between 0 and 2 pi. So we are only supposed to get 5 answers. So these are the 5 answers we get. Okay, so they're asking us to get the 5 roots, right? Yeah, in the form REI theta, where theta is between 0 and 2 pi. So these are the 5 roots. Yes. Alan. Question number 2, use algebra to determine the set of values of x for which x over 2 minus x is less than or equal x plus 3 over x. So, traditionally this is a inequality sign. You can't move x to the other side and 2 minus x to the other side. And the reason why you can't do that, right? X is a variable and we do not know whether it's a positive figure or negative figure. Therefore, if you move it, we do not know whether inequality mark should stay or flip. So you cannot move x terms to the other side. So to make sure there's no difference, what do? We take the inequality and what do? We multiply both sides with the square, right? So we multiply both sides with square numbers so that it doesn't, it prevents any problems with flippings. So we multiply both sides with the denominator square, x square 2 minus x square. Here also I multiply with x square 2 minus x square. I'm doing the same thing to both the sides. So I end up getting here x square. One of the 2 minus x will cancel off. X square 2 minus x into x. Here, of course, you have 1x remaining. Right, so you have here x times x plus 3 times 2 minus x square. Okay, I can simplify it. This is x cubed times 2 minus x, right? This is x times x plus 3 times 2 minus x square. Can all of you see this? Now, what we need to do is take everything to one side like I prefer now. I think we can see we have a minus x to the power 4 here. Can you see? Like because I want to I'm trying to keep my the highest power positive. So it's easier to factorize. Here I can see a negative x is getting square. It's a positive x square. Along with this x and this x, it's going to be a positive x to the power 4, right? So what I'll do is I'll bring this guy here. It will be easier. Okay, so then this is 0 and this will be x times x plus 3, 2 minus x square minus x cubed times 2 minus x. So now take the common thing out. X and 2 minus x. We don't go to open the bracket. Do not go to open this bracket. That's the worst thing you can do. Okay, because if you open the brackets, you will be in a lot of trouble. When we get sums like this, the best strategy is take everything to one side and then take the common thing out. Take the common thing out. And then what's remaining when you take x and 2 minus x out? X plus 3 and 2 minus x. Here what's remaining? Minus x square. That's all that's remaining, right? So now it's time to expand the bracket. So expand this bracket and you need to factorize it. So let's do that. Expand the bracket and factorize it. Now let's simplify inside. What do we get here? 0 less than or equal. Here we get x. 2 minus x. So what comes inside the bracket? So let's open the bracket. X into 2 is 2x. X into minus x is minus x square. 3 into 2 is plus 6. 3 into minus x is minus 3x. And I end up getting a negative x square term, right? So I think you guys took it to the other side. I was trying to get not get the minus x square, but I ended up getting it. Okay. So anyway, we can fix this. Let's try to do this. X times 2 minus x. Let's add everything. Minus x square is minus 2x square minus 1x plus 6. Okay. So now let's try to factorize this. The thing is this. When you go to factorize with the cal, you know when there's a negative value, it doesn't the factors doesn't come properly, right? So take the negative sign out. I mean, you guys took it to the other side and did it, right? Okay, so if you give the factors with the negative signs in the calculator, then your factors will not be correct. Okay, because if you the thing is this, look at this. Okay, the thing is this, once you factorize, now you're trying to factorize this, right? And then your two factors need to actually give you the same person once you open it again. Okay, so if you type this ABC in the calc, so do not do these mistakes like people do it like very often. So in the calculator, if you go to the equation, okay, so you get here minus 2, you get minus 1 here, and you get plus 6 minus 1, right? And you get plus 6, and you can see here you get x equals 3 over 2, which means basically the factorization is 2x minus 3, and this is minus 2. So 2x minus 3 and minus 2, but this is wrong. X equal 2 or minus 2, was it?
2x minus 3.
X plus 2, right? So x plus 2, 2x minus 3, okay. So now is this correct? Are these two brackets properly representing the top person? No, 2x into x is 2x square, not negative 2x square. So this is wrong, the factorization. So I have told you when you are doing these kinds of factorizations, I mean, you need to be able to get this person properly. You make a mistake like this and your answer will be totally wrong. Okay, take a minus sign out. Okay, take a minus sign out. Okay, so let's, what I'll do is children, before you factorize, listen, before you factorize, take a negative sign out. Okay, so negative sign out and I get 2x square plus x minus 6. Are you with me? So then I get here, and I'll take the negative sign here, x times 2 minus x times. Now I can factorize 2x square plus x minus 6 also will have the exact same factors as earlier, right? 2x minus 3 and x plus 2. It will have exactly the same factors. Okay. So the thing is this: if you want, you can put this negative sign inside one of the brackets, just one, or else you could take this entire thing to the other side and make it a positive. Like any way you want, you could treat this. Shall I take this whole thing to the other side? X times 2 minus, I mean, regardless of which method you approach, your answers won't change. There will be no difference. If you choose to keep the negative sign here and do the work also, it's fine. Or if you bring it to the other side, so shall I just keep it like this and do the work? No, we'll keep it like this. It's perfectly fine. Okay, we'll keep it like this. So now how do I get the answers? So how do I get the answers? I need to get the set of x values, right? How do I get the set of x values? Basically, first thing you need to remember is looking at the original sum and looking at the x values that you're supposed to remove from the domain. So because when you look at these fractions, you can see you have 2 minus x in the denominator and x in the denominator. So you know when x becomes what? 0, and here when x becomes 2, you get math error. First thing to do is to remove x equals 0 and x equals 2 from your domain. X equals 0 and x equal 2 should not be a part of your answer in any instance. Okay, so that needs to be written down first, because we need to make sure that they don't come into our answers at all. Okay, and then what we do is you can leave the inequality sign here and get the answers for each and every one of your brackets. So you have x here, 2 minus x, 2x minus 3, x plus 2. Basically, each x value, each factor gives you a solution for x, right? So here, just x means what? Like you imagine this equal to 0. Just x means you get x equals 0. 2 minus x means you get x equals 2. 2x minus 3 means you get x equals 3 over 2. And the other one is x equals minus 2. So you could draw a graph. Some people draw graphs. Some people just, you could simply draw a number line. It's a lot easier. Okay, if you want, you could sketch the graph, the graph with 4 rows. So basically the values I have minus 2, 0, 2, sorry, 3 over 2 and 2. And now you can divide your graph into regions. Basically what you do is you type the thing in your cal, and we need the region what? We need the graph, this section to be greater than 0. I need, according to the way I have done, I need this to be greater than 0. I need to select the ranges that give me answers that are positive. So what we could do is, I could take the cal here. So I'll take the cal and I'll type this entire section, negative x times 2 minus x times 2x minus 3 times x plus 2. So I'm typing the whole thing in the cal. Okay, I'm typing the whole thing in the cal. Can you see? Minus x, 2 minus x, 2x minus 3, x plus 2. And I'm going to input x values and check whether it's positive or negative. So in the first range, less than minus 2, take any x value you want, less than minus 2. So calculate x is minus 3 and I get a positive answer. Can you see? Even if it's minus 3 or even if it's minus 4, anything inside this range. Okay, even if you put minus 3.5, minus 2.5, whatever it is, you can see I get a positive answer here. So basically this part is positive. Is that okay? Yeah. So I mark this section positive. Between minus 2 and 0, input a value between minus 2 and 0. Between minus 2 and 0, if I give minus 1, you can see I get a negative figure, which means basically this part is negative. Between 0 and 1.5, between 0 and 1.5, I can give 0.5, I can give 1, anything. So I can say I'm getting a positive figure. Okay, so I'm getting a positive figure here between 1.5 and 2. So between 1.5 and 2, we'll have to give a decimal figure, right? So 1.6, 1.7, anything. So I'm getting a negative figure. And after 2, check the range after 2. So after 2, give a value. When x is 3, anything. X is 4. So I'm getting a positive figure. Can you see? Now it's time to write the answer. So I need this value to be greater than or equal 0. So it needs to be positive. So positive means which regions? I have here 1, 2, 3 regions where x is positive. So I end up getting here what? X is, because it's in this region, it's going to be what? Less than or equal minus 2. The equal mark comes here because the original sum has an equal mark. Can you see? The original inequality has an equal sign, so I must put the equal mark. The other one comes where x is greater than 0 and greater than equal 0, less than or equal 3 over 2. The next one is, yeah, we'll remove the inequality, equal signs. Minus 2 here. X is less than or equal minus 2. X is between 0 and 3 over 2. The next range is what? X is greater than or equal to. However, you know that there are things we need to remove here, right? Why I told you in the initial range that what I told you in the initial range we wrote down here that x equals 0 and x equal to is not supposed to be a part of your answer because they may give math error to the original sum, right? The asymptotes. So x equals 0 and x equal to should not be included in the answer. So I can see x equals 0 and x equals 2, right? Or minus 2, x equals 2. So x equal 2 and 0 must be removed. So basically you need to take care of these two equal signs. So you need to remove them because x equals 0 and x equal 2 should not be a part of your answer. Those parts need to be removed. Okay, so this is your answer. The three sets of ranges where that particular inequality is satisfied. Okay. Okay, question number 3. A transformation maps points from the z plane where z equal x plus iy to the w plane where w is u plus iv. The transformation is given. Okay, so they have given you how the z axis coordinates, how they are transformed to the w axis. Okay, so this is the rule, how it's moving. Then they are saying the transformation maps the imaginary axis, but basically the y axis in the z plane onto a line L in the W plane. So they're asking you to determine the Cartesian equation of L, giving you an answer in this form. Okay, so the transformation maps the y-axis. Okay, so what we'll do is this. First thing is when they give you a question like this, the easiest thing we could do here is let's make Z the subject first. Okay, let's make Z the subject first. Then we can replace Z with x plus iy and w with u plus iv. And then I can, what we do is we separate the real and imaginary on either side. And then we equate the real coefficients and the imaginary coefficients. That's what we need to do. So let's do that. So here first what I'll do is I'll bring the z minus I to the other side. W times z minus I equals 2 plus I times z plus 4. Okay, so when I open the bracket, I get here wz minus wi equal to z plus zi, right? Yeah, 2z plus zi plus 4. So let's bring all the z terms to one side and the ones without z to the other side, right? So here I have wz I'm keeping here. The plus 2z comes here as minus 2z. Plus zi comes as minus zi, and I will, the 4 is here. Minus wi goes to the other side as plus wi. Is that okay? Is that okay? Minus wi goes as plus wi. Okay, now I'll take this z out. I get here w minus 2 minus I equal 4 plus wi. Is that okay? Then let's replace z equals 4 plus wi over w minus 2 minus I. So I ended up making z the subject. So now let's replace z with x plus iy, w with u plus iv. So here 4 plus w is u plus iv, w is u plus iv minus 2 minus I. Okay, so then you can see now automatically now I have several problems. Can I immediately separate real and imaginary now? I think you can see I have ui, here I have I square v. Can you see on the top? And denominator, I have u plus, let me separate u minus 2 because I want to separate real imaginary even in the denominator, u minus 2, and I have iv minus I, right? So if I take I out, shall I write immediately v minus 1 times I? Okay, u minus 2, iv minus I took the I out, v minus 1. On top I have 4 plus u, 4 plus the bracket here, u plus iv, expand with the I, ui plus I square v. So let me fix it further a little bit more. You know, I square becomes what? I square is minus 1. So basically this is minus v. So let me bring the minus v near the 4 minus v plus ui because it's easier to keep our real and, better to separate our real and imaginary. U minus 2 plus v minus 1 I. So this is the first thing that I'm starting. Okay, so we are not done yet. Now we need to what? Remove the I from the denominator. Now I need to remove the I from the denominator. Okay. So now it's time to remove the I from the denominator. So let's multiply both up and down by what? I need to remove I from the denominator. That's what I want to do. So multiply with the opposite sign of your denominator, which is u minus 2 minus v minus 1I, because I need to change signs of my imaginary part. Change side. This guy should become minus, and then whatever I multiply my denominator, I must multiply with my numerator also. So this is what happens. So basically on top I get here. So I'm not going to do it individually. We'll take it, we'll multiply the bracket with the bracket, right? So what do I get here? On top I get the 4 minus v multiplying with the u minus 2 first. 4 minus v times u minus 2. Next one, I have the 4 minus v multiplying with minus v minus 1 into y. So plus value into a minus means it gives me a minus of 4 minus v minus 1 into I. Is that okay? And then let's move on. The next one I need to do is I have to multiply this ui with this u minus 2. So it's a positive, right? Positive u times u minus 2. I'll write I in the corner because I prefer to see I in the corner to clearly see it as imaginary, because if I write it in the middle, there's a chance, we may miss it and we may forget it. So whenever you have I, make sure to write it in the corner so you can clearly see it's imaginary. Last one is we multiply the ui with minus v minus 1I. So basically first thing is plus into minus is a minus. Okay, and then u times v minus 1, and the next thing is I and I multiplies to give you I square. So that's really important. You get I square in the denominator. Okay, numerator. So numerator opening is the only one where you have to go through all this trouble. Denominator, you don't need to do it like that. Why? Because the whole point of multiplying with the opposite sign of this guy is so that we have something like a plus b, a minus b, difference of 2 squares. When you have a plus b into a minus b, it's basically a square minus b square. So this is your a, u minus 2 is your a, b minus 1 is your b. B minus 1, minus 1, I is your b. So we can directly use difference of 2 squares, or else you could manually open and the middle part would cancel out. So no need to do that. We need to save our time as much as possible in this exam because it's really time constraint. So u minus 2 square, a square minus b square. V minus 1 square, I square. Don't forget to square the I as well, because your b includes v minus 1I. A square minus b square. So then we get here, we need to separate once again the real and imaginary. So let me deal with the numerator first. So in the numerator, you can see I have I square. Can you see? Because I want to take the real and imaginary. So here I square becomes what? Minus 1. Basically, this term becomes a positive. So shall I bring and it becomes a real term. Can you see? So shall I bring this real term near the real term? Because this guy also doesn't have a I. So we can bring them close together, right? So I'll bring them close together. I get here 4 minus v u minus 2 plus u times v minus 1. So this person is kind of like together, like the real section. Then here I get minus 4 minus v minus 1I plus u minus 2I. So what I'll do is, shall I remove I from both of them? And I'll put a plus mark in the middle. Okay, and then inside that you can put the whatever the signs you are putting. Do not make mistakes with signs. So minus 4 minus v minus 1. Can you see I'm talking about this term? Can you see the negative mark is inside? Minus 4 minus v minus 1 plus u times u minus 2. And this is the entire section who has the I. Can you see this person is the real part? This is the imaginary part. Okay, divided by u minus 2 square. And you can see on the denominator also I have I square. I square becomes minus 1. So it is plus v minus 1 square. So I think you can see now we are ready. I have kind of like my real terms and imaginary term. The I is there only in the numerator. Okay, so we didn't go through a lot of trouble. If you go to open these brackets individually, it will take a long time and it will waste a lot of precious time. So better to open it, do it with the brackets. Do not go to open the brackets at this stage. When we really need, we'll go there. So let me separate real and imaginary. You can separate your denominator, right? 4 minus v u minus 2 plus u times v minus 1 u minus 2 square plus v minus 1 square. This one minus 4 minus v minus 1 plus u times u minus 2 over u minus 2 square v minus 1 square. This whole thing is with I, right? Can you see I have separated my real and imaginary? So this is the real part, this is the imaginary part, and this whole thing is equal to what? X plus iy, because you remember we had this equal to z, right? So z is x plus iy. Okay, so first thing you do is you simplify your sum to this possible step. Okay, after you come to this stage, now look, what are we transforming? Now they say the transformation, what are we moving? So basically now you need to check what we are moving. They are saying the transformation maps the imaginary axis. Imaginary axis is the y-axis. So what happens on the y-axis? The transformation maps the imaginary axis in the z-plane onto a line L. So imaginary axis means what at the y-axis, that's true, but what's the equation of the y-axis and what's special about the y-axis? On the y-axis, it's x equals 0, right? Basically because all the x coordinates are 0. Y-axis means basically x is 0, isn't it? So then what do we need to do here? Let's go to our equation where I have separated, and now I can take my real and imaginary coefficients. So I will take the real coefficients. So I will take the real coefficients. Okay, and then my real coefficients are x equal. Okay, my real coefficients give me x equals 4 minus v, u minus 2 plus u times v minus 1 over u minus 2 square plus v minus 1 square. And what happens? Because we are transforming the x equals 0 line, I mean basically x is what? 0, the real, because they have told us x is 0. That line, that's the line that we are moving. So then x is 0. That's it. X equals 0 equals 4 minus v, u minus 2 plus u times v minus 1. I think you guys can understand that this denominator, when you multiply with 0, it will go away. So I can save some steps, right? I'm writing sometimes some extra steps to make you guys understand, but we can try to reduce them. Okay, so then there was a show that, right? Yeah, they were asking us to get the equation. Let's open the bracket. 4 into u is 4u. 4 into minus 2 is minus 8. Minus vu. Minus v into minus 2 is plus 2v. This is plus uv. This is minus u. So this cancels. Minus vu plus uv cancels. So I get here 0 equal 4u minus u is 3u plus 2v minus 8. So 3u plus 2v minus 8 equals 0. Isn't this the show that they had asked us? Show that you get the answer in the form AU BV plus C equals 0, right? That's what we got. AU BV plus C equals 0. ABC are integers. Yeah. So this is it. And you can see these are not multiples also. When you get these answers, check whether you have multiples. If they are multiples, it's better you simplify it, okay? So here 3 to 8 are not multiples. So this is it. This is your simplest answer. Is that clear? Okay, question number 4. Determine the general solution of the differential equation x plus 1 dy by dx minus xy equal e to the power 3x. Okay, so how does this one work? Now you all know when it comes to first order differential equation, we can either try to separate the variables, or we could try to use the product rule, or we could use the integrating factor method. There's no substitution given here. So we can see here, obviously separating variables will not work, where I can try to separate y and x term. That will not work. So even the product rule, if I'm correct, I can't see that working here. So we'll go with the integrating factor method. To go with the integrating factor method, you must your equation must look like this, right? Yes. dy by dx plus py equal q. This is the format for the integrating factor, where what p and q are functions of x. Okay, so this is how it works. B and Q must be functions of X. So if I look at my equation, I can see this equation doesn't look in the format where I can use the integrating factor. The reason being there's a X plus 1 in front of dy by dx. So I end up getting here, what I'll do is I need to make dy by dx, I need to keep it alone. So what I'll do is I'll take this equation and what? Entirely divided by X plus 1, because then I want to get it to that particular format. So we'll get it to that format by dividing the entire equation with x plus 1. So what do I get here? X plus 1 into 1 over x plus 1 will cancel, right? So dy by dx stays here, minus x times x plus 1 y equal e to the power 3x over x plus 1. So this is what we get. So now the next thing we need to do is we have to get our integrating factor. So when you have your equation in this form, the integrating factor is e to the power integration of this p with respect to x, right? So we integrate this p value with respect to x. So here, I think you can see here, the p value is actually what? It's not x over x plus 1. It's minus x over x plus 1. Please do not make these simple errors. You can see there's a plus mark here, not a minus mark here, right? So it's a plus mark here, which means your p value should be negative x over x plus 1. So then your integrating factor e to the power integration of minus x over x plus 1 with respect to x. So this is what we need to integrate. Okay, so now you need to decide how are we going to integrate minus x over x plus 1. So what's the strategy to use? Can I use f dash x over fx, the P4, P3 rules, reverse chain rule? No, it doesn't work because the denominator's differentiation is supposed to be 1. There's an x on top. So that doesn't work. So what's the strategy that you guys are going to use to integrate here? So think about the strategy that you are. Okay, so to integrate this, we have like many techniques we could use. One technique is where, because the this is actually an improper fraction, right? Because the power of the numerator and denominators are matching, it's a improper fraction. You could try getting partial fractions and then differentiating the partial, integrating the partial fractions. Or the simplest method is where you could just, because we can see there is x on top, x plus 1 in the numerator, denominator, you could add 1 and subtract 1. Even that method, that technique also works. I think that is the easiest. Shall I show you that technique? You could use partial fractions. So minus x over x plus 1 is basically, you can see here, because the powers are equal, you must put a constant and then write the partial fraction b over x plus 1. You could get your a and b values and integrate. So that also is one option. Or the easiest option that we can go, the easiest option here is where you have here minus x over x plus 1, right? So then whatever you do, you must not make any difference to the sum. So I will subtract 1 and add 1. Look what's happening. You can see here, I input a minus 1 and a plus 1. Now inputting a minus 1 and a plus 1, does it make any difference to this sum? I still end up getting the same sum, right? So then I end up getting here, basically this is getting the answer for the partial fraction in one go. Okay, this can be done because the numerator and the denominator, the powers are matching. That's why this method can be done. Otherwise, you will definitely have to go for partial fractions. So this is e to the power. Let me separate minus x minus 1 over x plus 1 and plus 1 over x plus 1. Can you see what I did here? I separated. And then can you see what's going on now? The minus, when I take it out, it is x plus 1 over x plus 1. And this is 1 over x plus 1. Can you see? So this is, and then I think you can see here these two guys cancel and you get here minus 1. So e to the power, I did it entirely inside the e. You could just do the integration separately and then use the answer inside. So e to the power minus 1 plus 1 over x plus 1. Can you see that I actually got the answer for the partial fraction here? So basically the a value is minus 1 and b value is plus 1. You could have gotten these two answers even by doing the normal partial fraction and taking the x plus 1 to the other side and doing the normal thing. Okay, so here this was a little bit of a different technique. So even that works. Anything. Okay, anything, all of these. Okay, so I have just shown how the if we use partial fractions, how the answers come. Okay, so basically, I end up doing the same thing. If you guys are not comfortable with this, go ahead with the partial fractions. Should end up giving you the exact same figures. Okay, no problem. Okay, so now these are integrating factor. Let's integrate this. So I still didn't integrate it yet, right? So e to the power integration of -1 gives me minus x plus 1 over x plus 1 gives me ln x plus 1. Okay, so then we can separate. This is a power. So you could separate this as e to the power minus x times e to the power ln x plus 1. We need to separate that plus mark. We can separate it as a multiplication. Then this becomes, you know what happens, right? E to the power ln x, or e to the power ln of anything is e to the power ln 2 is 2, e to the power ln x is x, this rule. So basically e to the power ln x plus 1 will be x plus 1. So you end up getting x plus 1 times e to the power minus x. This is your integrating factor. This is an integrating factor. Now what we need to do is take your equation, the one that we rearrange to get the integrating factor, and multiply that equation with x plus 1 times e to the power minus x. So the equation that I've rearranged to get the integrating factor was this, right? dy by dx minus x times, let's write it down, dy by dx minus x times x plus 1 into y equal e to the power 3x over x plus 1. So this equation I need to multiply it by my what? By my integrating factor. So integrating factor is x plus 1 times e to the power minus x. Is that okay? So then let's multiply it. So I get here x plus 1 times e to the power minus x dy by dx. So when you multiply the second term, x over x plus 1 with x plus 1 e minus x, the x plus 1 cancels. Right? I don't need to write extra steps for that, right? Yes. X times e minus x times y. Is that okay? Is that clear? I multiplied this with this. X plus 1 cancelled out. X and e minus x remains. Equals x plus 1. Again, when I multiply this row, it also x plus 1 cancels. E3x into e minus x is e2x. So I end up coming to this point. So now, when you after you multiply with the integrating factor, it should be possible to apply the the product rule. Like we should be able to write the two products who actually produce this, right? So I must be able to get the two products who actually differentiate to give me this answer. So basically, I can see dy by dx here, which means what? Dy by dx I get when I differentiate y. So product rule when we apply, and if we get dy by dx when you differentiate y, you know the other guy in product rule has to stay while the one person differentiates, right? So then I am suspecting my answer here to be x plus 1 e minus x is part of the original function. Dy by dx comes because I'm differentiating y. Okay, shall we check if that works? D by dx. So I'm suspecting this should be d by. This particular function here should be the d by dx of x plus 1 e minus x y. Okay, so I think we don't need to actually waste time. We don't have the time to actually check in the exam. So if you do this correctly, you don't need to be worried. Otherwise, you can open the bracket and check. So you can open the bracket and check it out, and you should be able to get this perfectly. Okay, so then this is the d by dx of x plus 1 e minus xy, and this is equal to e to the power of 2x. Okay, is that okay? Any questions to ask? Okay, so we come to this point where I apply the reverse product rule, okay? And then after you get to come to this point, we integrate both sides, right? This is how we do this sum in F2. So now the d by dx, and when we integrate, you know, this is the original function that I differentiate to get this. So this one, when I integrate, I should get back this guy, right? So I end up getting x plus 1 e minus x times y equal integration of e2x will give me e to the power 2x divide by 2. Remember, we are integrating, okay? So half e2x, and don't forget to put the plus c. Put the plus c at the moment you finish your integration. Have they asked us to make y the subject? Have they asked us? Yeah, giving you answer in the form y equal fx. So they have asked you to very clearly to make y the subject, which means you must make y the subject. So make y the subject, I end up getting here. X plus 1, e minus x will go to the other side as a division. So I can take it down to both these terms separately. Shall I take the x plus 1, e minus x to the denominator of these two guys separately?
Okay.
So y equal e to the power 2x over 2 times
X plus 1.
x plus 1 e minus x, and this is c over x plus 1 e minus x.
Yeah.
Okay, so it's e minus x. If you want, you could bring it up. When e minus x comes up as e plus x, here e2x into e plus x is e to the power 3x over 2 times x plus 1 plus c ex over x plus 1. Like this would be like the most simplified format. Okay, this can be a more simplified. Even if you leave your answer at this point, it's okay. Just you need to make sure what y is subjected, and they'll be okay with it. As long as y is subjected, you'll be fine. I just did an extra step here to make it look better. Okay, right. Okay, then let's move on to part B. Determine the particular solution. Okay, so we found the general solution. The reason they say it's a general solution is because your answer comes in terms of the constant c, right? So that's why it's a general solution. So then particular solution means where you actually get the value of that constant, the c constant, and they have told us determine the particular solution of the differential equation for which y is 5 when x is 0. So y is 5 when x is 0. Part B, y is 5 when x is 0. So let's input that. Y is 5 when x is 0. So e to the power 0 over 2 times 0 plus 1 here. C e to the power 0 over 0 plus 1. Are you okay with that? Replacing all the x values with 0, replacing the y value with 5. So we know e to the power 0 is 1, right? So I end up getting here 5 equals 1 over 2 into 0 plus 1 is 1. So basically 2 plus c over 1. So I can now make c the subject. So c equals to 5 minus half, which is 4.5 or 9 over 2. So now let's write the general solution. Y equals, input the c value to this equation, the c value of 9 over 2. Y equal e to the power 3x over 2 times x plus 1. C is 9 over 2, right? So 9 the 2 I can write it down. 9 over 2 x plus 1. So I think I can see we can leave your answer in this format, or 2x plus 1 is common. We could make it into a common denominator and add the numerator. So anything is fine. As long as y is subjected, we are good. Okay, so this is the answer for question number 4. Okay, question number 5. Given that y equal tan square x, show that d cube y by dx cube is, okay, this equation where p and q are integers to be determined. Okay, so basically we have to differentiate this guy thrice. Differentiate this thrice to get this show that. So I have taken the integration rules here so that it's easy for us to refer. Okay, so these are the rules I have written in terms of fx. Okay, so first things first. Integration of tan square. Now, you know, we don't integrate tan square. We know how to integrate tan, but there's no tan square. So basically, what we do is tan square is referred as tan x to the power 2. And you go with rule number 1. Here, this fx in rule number 1 is the tan x. The n will become the power 2. So that's how the differentiation works. Y equal tan square x is basically tan x to the power 2. So let's use rule number 1. Dy by dx, the power comes forward. Can you see the power comes forward? We subtract 1 from the power. This is differentiation, right? So tan x to the power 1. So after you're done with that, you know, after you're done with the power, we differentiate inside fx. The f dash x is the differentiation of the inside function. So inside function is tan x, and I need to differentiate tan x. So tan x differentiation we have in rule number 7. Tan differentiation is sec square. Sec square. So this is just x. Okay. So tan differentiation is sec square x, and then into the f dash x is differentiation of x, which is 1. Do you agree with me? Yes. So let me write dy by dx again. Dy by dx equals to 2 tan x. 2 tan x into sec square x. That's it. 2 tan x into sec square x. So that's what we have. So this is dy by dx. Now I need to go for d square y by dx square. Okay, so I think in my shoulder also I can see that I have a tan x square. Okay, let's try to go on. Differentiating this again. So now we are differentiating again. You can see you're going to run into some problems here. Number one, I can't differentiate both of them together at once because there's a product here. So we have to use product rule where one person stays, the other one differentiates. So 2 tan x, keep it waiting, and the sec square when you differentiate. So sec square differentiation is also going with rule number one, the power priority rule. So sec square differentiation is 2 sec x, because sec to the power 2, 2 sec x power 1. Take the 2 in front, subtract 1 from the power, this rule. And then into the inside differentiation, into the sec differentiation. What is sec differentiation? Sec differentiation is sec x tan x. Right, so this is keeping 2 tan x, 2 and tan x waiting while sec square differentiating, I get that. And then I'll write plus, and now the 2 is anyway a constant, it will anyway have to wait, and now the sec square waits. 2 sec square waits while tan x differentiates to give me, tan x differentiates to give me sec square x. So let's simplify this a little bit because I had to integrate this, differentiate this once more, right? I had to get d cube. So this gives me 4 tan x. No, sorry, I can get here tan x, and tan x gives me tan square x, right? 4 tan square x, sec square x, plus 2 sec to the power 4x, 2 sec to the power 4x. Okay, and then we need to do this again, right? But before we do this again, can't we try to simplify this a little bit, because I'm seeing sec to the power 4 tan square, which I don't even have over here in the d cube. You can see the d cube doesn't even have a tan square. So let's try to simplify, because if I go like this, let's try to simplify this a little bit. I think we can take the common thing out, right? We can take 2 sec square x out. It would be easy if we take it out. 2 sec square x, when it comes out, I end up getting 2 tan square x plus sec square x. This looks a little easier. Even if we apply the product rule, we can easily apply the product rule to this guy, because this one differentiates separately, this one differentiates separately, right? 2 sec square x plus into 2 tan square x sec square x. Okay, then d square y by, okay, so I can't, let's differentiate now, right? So I can't, let me keep it like this, let's differentiate d cube y by dx cube. Okay, so I will keep 2 sec square x, it's again product rule, right? 2 sec square x waits while these two guys differentiate. So tan x to the power 2, so again the power priority rule, right? The power 2 comes forward and I get here 4 tan x to the power 1. And then after that, tan x differentiation, because into f dash x, tan differentiation is sec square x into 1. And then, so here basically it's addition. So I can easily differentiate this guy plus, and I can go for the other guy, right? Sec square, again the power rule. So sec square, the power rule is 2 sec x to the power 1 into sec x differentiation is sec x tan x. Okay, so this is that part. This is just this part only. Okay, then after that I need to keeping the bracket constant, I'll differentiate sec square. So now plus the 2, yeah, so now plus the 2 and 2 tan square x sec square x is waiting while the sec square x, this sec square x differentiates. Are you with me? These two guys are waiting because we are applying product rule. Now the sec square x differentiates. So again power rule, 2 times sec x to the power 1 into sec x differentiation is sec x tan x. So it's quite long, right? Okay, so then let's do this. I mean, if you wanted, you could have like differentiated even this rule. Okay, so I took the sec square out and differentiated here. If you wanted, you could have even taken this d square y by dx square and gone ahead. Okay, So there's no problem. Okay, now let's try to get our show that d cube y by dx cube equals to 2 sec square x. Let me try to simplify it. I get here 4 tan x sec square x plus I get here 2 sec square x tan x and then I get here plus yeah, these two guys are all this is inside the bracket plus mark. These guys all come outside, right? Plus this is 2 times 2. I can multiply this 2 and this 2, which is 4 6 square x tan x, right? 4 6 square x tan x into 2 tan square x plus 6 square x. You know, we could have made our life a lot easier actually here in the earlier step. So I think you can see the differentiation is really long, right? So when I just look at this, it came to my mind right now that we could have used 1 plus tan square instead of 6 square. But still, that's also wrong. 1 plus tan square is 6 square. And then because in that case, we get only tan squares here. Wouldn't that be easier than this? Even this is okay, but like using 6 squares, 1 plus tan square, and I can get here 3 tan square x plus 1, which will remove one whole entire section. Shall I do that? Because I think that is a lot easier than going like this. Okay, even this is okay. Let me keep it like this and let me try like this because this. Okay, let me go like this. I think it will save us a lot of time also. So this of course comes with practice. Okay, I was 2 tan square x. I'm trying it from here. Okay, 2 tan square x. The sec square x, I'm replacing it with 1 plus tan square x. Are you with me? Okay, because it helps me because it removes one whole section. I mean, to differentiate. And then 2 tan square plus tan square is 3 tan square x plus 1. Isn't this a lot easier to differentiate? It's a lot easier to differentiate, right? So now I can get d cube y by dx cube. Okay. Okay, so then we can use product rule now. 2 sec square x weights. Okay, let's differentiate 3 times square x. So this becomes the power rule for 3 times 2, 6. Tan x to the power 1. Then tan differentiation is sec square. Okay, and then plus 1. See, this is where it becomes easy. Plus 1 differentiation is 0. So it's done. The rule is actually it's a lot shorter. And then plus now the 3 tan 2 times 3 tan square x plus 1 weights. 2 times 3 tan square x plus 1 weights while the sec square differentiates. So sec square differentiation also the power priority rule. So sec square differentiation I kept these two in front, right? You can see the 3 tan square x plus 1 is here. These two guys are what I have written over here. I'll differentiate sec square now. So I end up getting a 2 comes in front. 2 sec x to the power 1. Sec x differentiation is sec x tan x. So this should be a lot easier to handle. D cube y by dx cube equals 2 sec square x. And this is, of course, there's no plus mark here, right? So I can immediately multiply, actually. This is into 6 tan x sec square. Okay. And then the other guy I get here plus, I can multiply the 2 and the 2 here. 2 times 2, that's a 4. The sec x is sec square x. And then I get here tan x times 3 tan square x plus 1. Is that okay? We need to get the show that now. D cube y by dx cube equals, I get here 2 times 6, 12 tan x sec to the power 4x, right? And then I get here, when I multiply here, I get 4 sec square x tan x into, okay, let me open that. 4 sec square x, no, 4 times 6, 12, right? Okay, I think I need to do something about this guy. The show that gives me what? The show that gives me 8 tan x square p x square. So there is a tan x to the power 4x and tan x square, right? So basically I need everything to be with tan x square and tan x to the power 4. Right? Tan x square and tan x to the power 4. Do I need a tan cube x? Now you can see if I multiply this tan x here, I get tan cube x, right? So that is basically not necessary. Shall I do a change, quick change here? Can you all suggest what's the change I should do here before I open the bracket? Tan x. Another thing is I don't need, I only need a single tan x, right? Yeah. We know 1 plus tan square is x square, right? So I can use tan square is sec square x minus 1. You know why? Because I want to see products of tan and sec square and tan and sec to the power 4. That's what the show that gives me. If I open this bracket here, I end up getting tan cube. I don't need tan cube. Okay, so to avoid the tan cube, 3 times the tan square is replaced as sec square x minus 1. And then I think we get the show that now after this. So after this point, we should get the show that quite easily. 12 tan x sec to the power 4x, and this is 4 into 3. Okay, so let me open the inside bracket first. 4 sec square x tan x, and I end up getting here 3 sec square x minus 3 plus 1. Minus 3 plus 1 is minus 2. Do you get it? 12 tan x sec to the power 4x, 4 times 3, 12 sec to the power 4x. Can you see? I get products that I want. Sec to the power 4x, tan x, minus 8, sec square x, tan x. Can you see? Everything is what we need in the show that. Sec square tan x and sec to the power 4 tan x is what our show that looks like. I think we have some like terms here that I can add. Sec to the power 4 tan. Yes, I have these two guys, right? So when I add them, I end up getting here 24 tan x sec to the power 4x and minus 8 sec square x tan x. Right? So the show that had taken a 8 tan x sec square x out, right? So I take 8 tan x sec square x out and I end up getting here 8 times 3, 24, 3 sec square x minus 1. So this is basically the show that, right? Okay. So this is basically the show that. Okay. Part B, hence determine the Taylor series expansion about pi over 3 of tan square x in ascending powers of x minus pi over 3 up to and including the terming x minus pi over 3 cube. So I think I have taken the Taylor series format here. So you can see there are, you can remember in your book, you have learned there are two types of Taylor series. One with ascending powers of x, the other one is ascending powers of x minus a. So they want here in ascending powers of x minus a, and you can clearly see because it's x minus a, your a value is pi over 3, and they have told it's pi over 3 as well, right? So then you need to get your expansion here and basically fill the values of fa, f dashes. So basically you have to get the values of your a value is pi over 3, right? So here because of this you figure out your a value is pi over 3, and then let's fill out the values. So I get here, I need to first get FA. Are you guys with me? I have to get the FA value, F dash A value, F double dash, and F3 dash, the third derivative. I have to get these three derivatives in order to get until the power x minus pi over 3 cube. Can you see? These are the only values I need to find. I just need to find them and substitute. So let's get the first one. So what's our fx first of all? Who is our fx? Our fx is tan square x. Okay, so then let's get the first one. A is pi over 3. So FA means f of pi over 3. In here, remember, the A signifies the pi over 3. So f of pi over 3. Let's input tan square pi over 3. Tan pi over 3 is tan 60, right? So which is root 3, which is square is 3. Am I correct? Am I correct? So the next one, f dash pi over 3. Actually, to get f dash pi over 3, f dash is your dy by dx. Am I correct? Can you see dy by dx here? Written? So f dash pi over 3 is the dy by dx. You need to replace the dy by dx, the x values with pi over 3. So 2 tan pi over 3 into sec square pi over 3. So let's get the answer. 2 tan pi over 3, cal must be in radian mode. And then I get here 2 tan pi over 3. 2 tan pi over 3 into, there's no sec square in the cal, so we give 1 over cos square. So to give cos square, you give like this, right? Pi over 3. And to make the function square, you don't give the power 2 in the middle, right? You put another bracket and then you give the square. Can you see how we give cos square? Cos pi over 3 is what you type. Sec is 1 over cos. So cos pi over 3 is what we type. To make it square, you need to give an extra bracket outside the cos pi over 3 and give. Otherwise, you can type cos pi over 3 into another cos pi over 3, okay? So this is the way we type it. If you don't give this extra bracket and just type the square, you know what's going to happen. The only the angle will be square. You get it? If you type the power 2 like this, this is completely wrong, okay? If you type the power 2 in this manner, because the power 2 now belongs to the pi over 3. The calculator assumes this the angle as pi square over 9. Okay, so that's wrong. So we need here to be a sec square, means I need my sec to be sec into sec, or basically 1 over cos into cos. The cos needs to be square. Okay, so be very careful when you're using the calculator. So the answer I get is 8 root 3. Is that okay? 8 root 3. Next guy, f double dash. F double dash pi over 3. So I get here d square y by dx square answer. I think I got it in a simpler format. Yeah, so we have d square y by dx square, 2 sec square, 2 tan square plus sec square, or I have it as 2 sec, this is the simpler version I got, right? 2 sec square x, 3 tan square x plus 1. 2 sec square x, 3 tan square x plus 1 is what I got for f double dash, right? So let me, this is f double dash x, I just wrote it here. So f double dash pi over 3, 2 sec square pi over 3, 3 tan square pi over 3 plus 1. So it's a matter of putting it in the calculator correctly. So input it in the calculator and try it for yourself. You cannot do it for the first time in the exam. Sec square is 1 over cos square. To give the cos square, you can see I'm typing an extra bracket from the moment I start. Okay. And this is pi over 3 close bracket and another bracket and a square. 2 sec square pi over 3. Then I take the first up and multiply with the other guys in the numerator, right? 3 tan square pi over 3 plus 1 is in the numerator. Make sure it's on top. Therefore, don't type this in the denominator, okay? So this is 3 times tan square, also better to give another bracket. Because or else you could type tan pi over 3 into tan pi over 3. Okay? So shall I type it twice? I mean, I'm just going to type it twice. Tan pi over 3. Tan square, again a tan pi over 3. I'm doing this so that it won't go wrong. Tan square is it's the same thing twice. Tan 3 tan square pi over 3 plus 1. And close the bracket. So let's check it again. 2 into, or else you could type it part by part and then multiply, like you get this part answer and then multiply, like any of those methods are okay. If you're typing everything in the cal at once, you need to have a very good idea of what you're typing. 2 over 1, 2 into 1 over cos square pi over 3, 3 tan pi over 3. You can see I typed tan pi over 3 twice because I feel there'll be a lot of, you guys might get complicated with too many brackets. So that's it. Equals 80.
Yes.
Equals 80. So this is the answer I get. If this is too complicated, please get each part answer separately and let it out. That's all. Simple thing to do. Then the third derivative is 3 dash pi over 3. I think that's the show that, right? So that show that we got was 8 tan x sec square x, 3 sec square x minus 1. 8 tan x is pi over 8 tan x sec square x, right? 8 tan x, 8 tan x sec square x into 3 sec square x minus 1. Am I correct? 3 sec square x minus 1, right? Am I correct? 8 tan x x square x, I mean, the show that from here 8 tan x x square x, 3 x square x minus 1, right? So now it's time to give the values. If this is too, I mean, if it's too much to give it everything at once, you could give it part by part. 8 into tan pi over 3 is, I mean, giving it part by part is also easy in a way. Tan pi over 3 is root 3. Tan 6 is root 3. Then sec square pi over 3 is 1 over cos pi over 3, right? So 1 over cos square pi over 3. Cos square pi over 3 is cos 60 is half, right? I'm giving the parts individually in the calc. Tan pi over 3 is root 3 sec square, or else we could type it the sec square value directly in the calc. So I'll type like this here. 1 over sec square is cos pi over 3 cos pi over 3 square. 1 over cos square. 1 over cos pi over 3 square gives me 4. Okay, so the directly I'll put 4 here into 3 times again sec square pi over 3 is 4 minus 1. So this is easier to work with. So I end up getting here 8 times 4, 32 root 3 times 3 times 4, 12 minus 1. So 11 times 32 root 3. 11 times 32 root 3, of course you can type it or leave it. Okay, so 11 times 32 is what I'm going to type because I'm getting a decimal answer. I don't want decimals. 12 minus 1, 11. 11 times 32. 352 root 3. So if the calculator gives you decimals, you must know. I think if I did this whole thing, if I gave this whole thing in the calc, I have a feeling I would have gotten a decimal. Okay, because this part itself gave me a decimal. So if I wasted time typing the whole thing, it would have definitely been a waste of time. So basically, in this situation, better to type people individually and then get, because we definitely need the exact answer. Okay, time to input our values into the equation. Time to input the values into our equation. So I have all the values. So fx, so basically fx is the tan square x. Tan square x equals fa. What was our f pi over 3? F pi over 3 is 3 plus f dash pi over 3 was 8 root 3, right? Plus 8 root 3x plus f double dash pi over 3 was 80. So 80 over 2 factorial times x, sorry, this is not x, right? This is x minus pi over 3. This is x minus pi. We are using the second format, right? F dash a is 8 root 3 x minus pi over 3 plus f double dash a is 80 over 2 factorial x minus pi over 3 square plus f3 dash was the 352 root 3. I'm using this one over 3 factorial x minus pi over 3 cube. So this is it. Have they asked us to simplify? Yeah, they want us to simplify, right? Yeah, up to and including, giving each coefficient in its simplest form. So let's simplify. 3 plus the 8 root 3, of course, there's nothing more to simplify. 80 divided by 2 factorial is 40, right? 40 x minus pi over 3 square. Can you all tell me 352 divided by 3 factorial is? 176 root 3 over 3 x minus pi over 3 cube. Basically, this is what you get when you type 352 over 3 factorial in the calc. You get this. So this is it. So this is the simplest answer, right? The scalar series expansion where we give each coefficient in its simplest form. Okay. Okay, the complex number z on an Argand diagram is represented by the point P where z plus 1 minus 39 equal 3 times z minus 7 minus 5y. Given that the locus of P is a circle, determine the center and radius of this circle. Okay, so how do we do this one? So basically here, I think you can see there's a 3 outside. So in the locus lesson chapter 4, complex numbers, we described 5 parts, right? So this is the one where there's a constant in front. So basically what we do is we separate real imaginary and then we square. We take the modulus of both the sides, right? So Z is x plus iy plus 1 minus 13i equal 3 times modulus is Z is x plus iy minus 7 minus 5y. So let's separate real imaginary x plus 1 times y minus 13 times I equal here 3 times x minus 7 times y minus 5 times I. Okay, so this is what you get. Now let's get the modulus. You know how we get the modulus? First you separate real imaginary. Modulus means what? You take the real part and square plus the imaginary part square and root, because this is basically modulus means the distance to this particular coordinate. Okay, so take the real part and square, take the imaginary part and square. Are you squaring the I? No, right? Because I is just the xy coordinate here. This is just a coordinate, and we are using Pythagoras theorem here. The x coordinate and for the y coordinate and the square root. This is what you mean by modulus. Here 3 times. This is x minus 7 square plus y minus 5 square root. Can you see? So now there are roots on either side, and you know you can't cut this square and this square with the root, right? Yeah, you can't write x plus 1 plus y minus 3. You can't do stuff like that. So what we'll do is to remove the large square, we will square both the sides. When you're squaring both the sides, the only thing you remember about here is this 3. The 3 also gets squared because I'm squaring both sides in the attempt to remove this large root. So I end up getting x plus 1 square plus y minus 13 square equal 3 square is 9 times x minus 7 square plus y minus 5 square. So I end up getting x square plus 2x plus 1. I open it immediately. Y minus 13 square is y square minus 26y plus 169. Here 9 times x square minus 14x plus 49. And y minus 5 square is y square minus 10y plus 25. Is that okay? So let's simplify like terms. X square plus 2x, y square minus 26y, 169 plus 1 is 170. I added these two guys. Is that okay? The other side I get here 9x square. 9 times 14 is 9 times 14, I get 126x plus 9 times 49, I get 441 plus 9y square. 9 into 10 is 90y plus 9 times 25, which is 225. So I need to simplify this as much as possible. So shall I do it at once? We really don't have time to take long cuts. So 9x square and the 1x square subtracts to give you 8x square. Is that okay?
Yes.
Minus 126x and the plus 2x goes as minus 2x to the other side, right? Minus 126x minus 2x is minus 128x. The next one, I have plus, no, we'll first do the y square. 9y square plus 1y square goes to the other side as minus y square. So that is 8y square. Then the next one is the minus 90y, the minus 26y goes to the other side as plus 26. Okay. Then minus 90y plus 26, minus 90 plus 26 gives me minus 64y, right? And then the constants, you have to get the constants together. So I have the constant plus 170 goes as minus 170. And these three guys, so 441, you have to add with 225. These two guys are adding, this plus 170 comes as minus 170. So I end up getting 496. Is that okay? Okay, so now it's time to, we need to get the equation of a circle. Clearly, they have told us it's the equation of a circle. I have to complete square, but I can't complete square when there's 8x square, 8y square. So the whole equation, I choose to divide it by 8. So I end up getting here 0 equal x square. 128 divided by 8 is 16x. This is y square. 64 divided by 8 is 8y. 496 divided by 8 is 62. Okay, so now it's ready. Now we can complete the square for each part. This part completes square separately. This part completes the square separately. So 0 equal x minus half the value of 16 is 4 square minus and 16. That's the completing square of these two guys. The other one is y minus half of 8 is 4 square minus and square of half of 16 is 8. Sorry, yes, I have made an error here. X minus half of 16 is 8 square minus 64 plus this is y minus half of 8 is 4 square minus 16, right? Minus 16 and yeah, plus 62. So I'll take all these constants to the other side. Minus 64, add it with minus 16 and minus 64 minus 16 plus 62. I get minus 18 here. Take it to the other side. I get plus 18. X minus 8 square plus y minus 4 square. So basically I get here, this is my r square, right? So it's a circle center. X minus 8 means 8 comma 4. And radius r square is 18, which means r is root 18. Square root 18 is 3 root 2. So it's a circle center 8 comma 4, radius 3 root 2. So this is the answer for part A. Okay. Okay, they are saying the complex number W on the same Argand diagram is represented by the point Q where argument W minus 8 minus 6i equal minus 3 pi over 4. Now, when you see this locus, first thing that comes into your mind is what does it represent? How does it draw? This is a half line. This is what we call as a half line, right? They are asking you, given that the locus of P intersects the locus of Q at the point R. So locus of Q is what we got in the earlier part, right? Locus of P is the circle. Locus of Q is the half line. So they want the points where the circle intersects with the half line. Are you all with me? So determine the complex number representing R. Okay, so basically one mistake that many people do here is they get the equation of the circle, which we have found in part A, and you can get the equation of the line you can get the equation of your half line, and you solve the two simultaneously, and basically you'll end up getting two answers. However, the thing is this, if you write both the answers, actually it's wrong. Okay, the thing is this, you need to have an idea, visually an idea of what's happening here. So let me give you a visual idea of what's happening here, because if you draw this inside your head, you will realize that there is only one cutting point, not two cutting points. Let me show you what I mean. So I have a circle center 8 comma 4, right? And radius is how much? 3 root 2. So roughly, let me draw. I'm just roughly drawing a circle center 8 comma 4. Okay. Circle center 8 comma 4. Radius is 3 root 2. Is it bigger than 4? It's bigger than 4. So that means it's going to go below the x-axis, right? Yeah. So this is the center. Basically, you get a circle like this, right? This is just a rough sketch. Okay, I'm just drawing a rough sketch. Then let's draw the half line, because I want to visually see what's happening here, what's going on here. This is the circle I got in part A. Okay. Okay, so argument 8. So let me write it here. Arc, you know how to draw the arc half line, right? So arc, this is W minus, you must take the minus mark out and then write remaining 8 plus 6i equals to minus 3 pi over 4, right? Minus 3 pi over 4 is how much of an angle? 3 times 180 divided by 4 is 135, minus 135 degree, right? So basically, what is this? When you look at this itself, you should know what we are talking about. It's a half line. Starting at the point 8 comma 6, making an angle of minus 3 pi over 4 with the theta equals 0 line. So the half line starts at 8 comma 6. Okay, where is 8 comma 6? Somewhere over here, right? Okay, 8 comma 6 is like above this. This is 8 comma 6, and then this is your theta 0 line, isn't it? Because from that point, the place where you mark, only you mark the theta 0 line. Are you with me? So, and then And then we are drawing the half line at this point. We have to take negative 135 degree, isn't it? So negative 135 degree will be like, you have to measure it from theta 0. We need to go back like this, and this is the half line you draw. This is a rough sketch, okay? I don't know whether it goes through the origin or not. I just drew a really a rough sketch. This is not at all accurate. But however, the important thing I want you to notice here is that what? This half line cuts the circle at only how many points? Only 1 point. That's why they say determine the complex number, not complex numbers. It's not in plural, it's in singular. So basically what people do is they get the equation of the circle and you can find the equation of the straight line, and what do? You solve, and basically if you get the straight line equation, we don't understand it's a half line. When you get a straight line, it considers the full line. And basically you end up getting both these answers that comes over here and here. So that is wrong because one solution is actually wrong. It's not a full line, it's a half line. So having this idea in your head only, you must get the Cartesian equation of your half line, because I need the Cartesian equation to get this point. Okay, so how do I get the Cartesian equation of the half line? So W is U plus IV, right? W is U plus IV minus 8 minus 6I. And then we separate real and imaginary. U minus 8 plus V minus 6I, right? Equal minus 3 pi over. So how do we remove argument? There's a way to do it, right? Tan inverse of imaginary over real, isn't it? We write tan inverse of imaginary over real equals to this minus 3 pi over 4. This is the way we remove the argument. So basically V minus 6 over U, V minus 6 over U minus 8, right? Over U minus 8, if a tan inverse goes as tan of minus 3 pi over 4. Are you with me? What is tan 3 pi over 4? Okay, tan 3 pi, it's in the same plane, right? I think for complex number W, I don't need to use U plus IV. Why is that? Because basically complex number W on the same Argand diagram, isn't it? So they just wanted to say it's a different part. That's why they use W. Earlier one they use Z because it's a circle. Here W is the half line. So instead of using U and V, let's actually use what? Let's actually use X and Y, because I'm going to solve a pair of simultaneous equations, right? So instead of using UV, let's actually use XY because it's on the same diagram, right? So in the same set of coordinates. So instead of using UV, let's use XY. So this is X and V is Y. Shall I remove all of this? Okay. So this is X plus IY. So this is X minus 8. This is Y minus 6. So Y minus 6 over X minus 8. This is Y minus 6. Okay, are you with me? Can you see the correction? Because we are under the habit of using W as U plus IV. Tan minus 3 pi over 4. Can I know the answer? How much? 1. Tan minus 3 pi over 4. Type it inside the cal. Tan minus 3 pi over 4 is 1. Simply 1. Just it's a matter of typing in the cal. Okay, so basically now the X minus 8 can go to the other side and you get a very simple Cartesian equation, right? Y minus 6 equals X minus 8 into 1 is X minus 8. You end up getting Y equal X minus 8 plus 6 is X minus 2. So this is the Cartesian equation of this line. Can you see? Because, and this doesn't understand, it's a half line. So when you say Y equal X minus 2, we consider this full line. Is that clear? We consider the full line. Now I need to solve this with the, I need to solve this line simultaneously with the, with the equation of the circle. Circle equation we got was X minus 8 square plus Y minus 4 square equals 18. So let's replace the Y with X minus 2. Y is replaced as X minus 2. X minus 8 square. So let's open the bracket. I get here X square minus 16X plus 64. Here I get X square minus 12X plus 36 equals to 18. I end up getting here 2X square minus 16 minus 12 is minus 28x. 64 plus 36 is 100, right? So when let's solve this, I end up getting here 2x square minus 28x. 100 minus 18 is 82. We can divide the whole equation by 2. So let's divide the whole equation by 2. I end up getting x square minus 14x plus 41 equals 0. So now let's type the answers. I could complete the square, or we could use the formula x minus 7 square, right? X minus 7 square minus 49 plus 41 equals 0, right? So x minus 7 square minus 49 plus 41 is minus 8. Goes to the other side as plus 8. Is that okay? So x minus 7, the square goes as a root, and when you are putting the root, remember to put the plus minus because that separates the two answers. So x minus 7 is equal to root 8 is 2 root 2, or x minus 7 is equal to minus root 8 is minus 2 root 2. So x equals to 2 root 2 plus 7, or x equals to negative 2 root 2 plus 7. Okay, so now we need to decide. So you know very clearly that there is only one correct answer because we saw in our diagram that this line meets the curve. I mean the half line is meeting at only one line. Yeah, so then the thing is this, both the answers are positive. However, you can see, if you check this half line, if I draw the full line, do you see this line extends the other way? So if you take these two answers, both the x answers you get are surely positive, but however, we need to take the small x value. Do you see this x value is comparatively larger than this one? So then the correct answer here is the small x value. Okay, so then out of these two guys here, okay, I take the smaller. The correct answer here is x equals to minus 2 root 2 plus 7. It's a positive figure, right? Yes. Minus 2 root 2 plus 7 is some 4.17. Okay, so basically this is the correct one. This one is a larger value, which is the other one which we don't need, corresponds to the large value. Now get the y value also. Y equals to x plus 2 or x minus 2. Y equals to x minus 2. And you can get your y answer. Y equal x minus 2 minus 2 root 2 plus 7 minus 2 minus 2 root 2 plus 5. So this is the x value and the y value. I think you can see in the question, they ask us to give the complex number, right? So they ask us to give the meeting point. Can you see? They are asking you determine the complex number representing R. The point R is the place where locus P intersects with locus Q. Locus P is circle, locus Q half line, intersecting point is point R. They want the complex number representing point R. So how do you give complex number? X is the real, Y is the imaginary. So give the complex number R. So R is 7 minus 2 root 2 plus 5 minus 2 root 2 I. So this is your complex number R. Okay, so I hope this is clear with all of you, and especially you, I hope you can understand why we don't take both coordinates. We take only the small x value here. Okay. Yeah. Okay, question number 7. Show that the transformation x equal t square transforms the differential equation this with y and x, right, into the differential equation with y and t. So basically they have removed whom? They have removed x. X is completely removed. Okay. So when they give us a substitution, even in second order, what we do is we first differentiate that given substitution, right? So x equal t square. Shall we differentiate this? Now I'll differentiate this with respect to x to start with, and then later we can use, I think we'll need to go for chain rule because we need to convert it with respect to t, right? Can you see in the show then? Okay, so when I differentiate with respect to x, what do I get? X differentiation is 1, t square differentiation is 2t. Are we done? Into dt over dx. Into dt over dx. So basically I can get dt over dx is 1 over 2t. Okay, or dx by dt will be 2t. If I write dx by dt, the upside down version is 2t. Okay. The thing is, I don't need dx by dt. I need to find a substitution to replace the dy by dx, because dy by dx has to be replaced by dy by dt. You see? So the way we do it is we write the equation for dy by dx. We break the dy by dx by using the letter t. So dy by dx we can break it by using the letter dy by dt into dt over dx. So I have dt over dx here. dt over dx is 1 over 2t. So basically dy by dx is dy by dt into 1 over 2t. Do you agree? Is 1 over 2t. Okay, so this is the substitution for dy by dx, right? Yes. Okay, this is the substitution for dy by dx. Okay. Okay, so we'll differentiate this again. I think it's better we keep it like this. Otherwise, if you want, you could have taken the 2t here and t is root x. Can you see? And we have 2 root x in the show that. Can you see? Okay, I think it's best we'll keep it here and like let's look after that later, right? Okay, then let's differentiate this again because I have to get the substitution for d square y by dx square as well, right? Okay, I think to differentiate d square y by dx square, it's easy if I bring the 2t here. Let me bring the 2t here. 2t times dy by dx equals to dy by dt. It's the same thing, right? It's the same thing. Shall I replace the x with root x? Would it be easier? Whatever the way we go, we can do it freely. There's no issue as long as we get the answer fast. Fine. I think if we use root x, it will give us x to the power minus half, right? That's a headache. Okay, we'll keep it like this and let's differentiate again. Okay, so let's differentiate this again. Differentiate with respect to what? Let's differentiate with respect to x. Okay, differentiate with respect to x. You could do with respect to t as well, okay? So when I differentiate with respect to x, I think you can see t is a variable. Okay, so it needs to be, we need to go with product rule here. So 2 and t weights, while dy by dx differentiates to give you d square y by dx square. Do I need to put into another additional term? No, I'm doing with respect to x. dy by dx also is with respect to x. So no need extra any other term. Then product rule now. Now the 2 and dy by dx weights. The 2 and dy by dx weights, and we multiply with, we need to multiply with the differentiation of t. So when I differentiate t with respect to x, what do I get? Differentiation of t with respect to x is dt by dx. Differentiation of t with respect to x is dt by dx. Okay, equals, let's go to the other side. I have dy by dt. Now remember, I'm differentiating with respect to x. Be careful here. Okay, this is the place where you could go wrong. dy by dt, when I differentiate with respect to x, first anyway do the differentiation. dy by dt differentiation will give you d square y by dt square. That you can't stop. That is the first thing you do. Then you realize you have done your differentiation with t here, but I need it to be done with respect to x. So I have done this with respect to t, right? So it should be, because we did this differentiation with respect to t, we write dt, and then we want it done with respect to x, so we write by x. So this is something you need to clearly understand. It's taught in the F2 book. So dy by dt with respect to x is d square y by dt square, the second derivative, into, since this is done with respect to t, we must put dt on top and over dx, because we want to convert it with respect to x. Okay, so now it's a matter of inputting the values. Okay, 2t d square y by dt square, d square y by dx square. Basically, I want to get d square y by dx square subjected, because I'm going to substitute the values, right? Do 2t d square y by dx square plus 2 dy by dx. Actually, 2 dy by dx into dt by dx answer we found, right? dt by dx answer we found on top. dt by dx is 1 over 2t. Equal d square y by dt square. dt by dx is once again 1 over 2t. Okay, so let me simplify. This is 2t times d square y by dx square plus the 2 and 2 cancels here. And I get here 1 over t dy by dx. Okay, actually dy by dx also I'll replace it, right? Because dy by dx is dy by dt into 1 over 2t. So let me replace the dy by dx here. This dy by dx is replaced as dy by dt into 1 over 2t. I don't need this extra bracket because it's actually a multiplication, right? Equals, this is 1 over 2t t square y by dt square. Okay. So what do I get here? 2t d square y by dx square 1 over 2t square, right? dy by dt equal 1 over 2t d square y by dt square. I think what I'll do here is I want to substitute d square y by dx square into this equation, right? So I'll make d square y by dx square the subject, meaning I'll take this equation and divide it entirely by 2t. Okay, so there are many ways of doing this. Okay, this is just one way that comes into my head right now. So divide by 2t in the sense I'm multiplying by 1 over 2t, isn't it? Yeah. I'm multiplying by 1 over 2t. Am I correct? Yeah, right? So when I make d square y by dx square subject, I get 1 over 4t square d square y by dt square minus 1 over 4t cube dy by dt. I have a feeling of, multiplying the whole thing by 4t square, and actually, 4t square would actually give me 4x. You see, t square is x. If I multiply the whole thing with 4t square, I get 4x also here. It's easier if we do like that, right? Because can you see this show that the original equation has a 4x? And if a 4x means a 4t square here, isn't it? Would be easier, right? And it would make all these division people also, it would make them disappear. So I'll multiply the whole thing by 4t square. Why? Because 4t square is 4x. Okay? 4t square d square y by dx square. This is d square y by dt square. Here the 4 to 4 cancel, 1t is remaining. Are you guys with me? When I do this, and then this 4t square is actually the x 4x. Are you guys with me? It's easier to substitute in this manner, right? You could reduce a whole number of steps. Okay, I'm writing extra steps to make things easier for you guys to understand. Okay, then shall we substitute now? So everything is ready. 4x d square y by dx square is ready. Okay, dy by dx is also ready. Let's substitute. So can you all tell me what is the substitution I got for 4x d square y by dx square? Let's open the bracket here. Okay, let's open the, no. Yeah. There's a lot of work to do here. I think there are 2 root x. We even have the 2 root x here, but there's extra part. Never mind. Okay, let's get it done quickly. 4x d square y by dx square. What did we get? And d square y by dt square minus 1 over t dy by dt, right? Plus 2 times 1 plus 2 root x dy by dx was, we found it, right? Dy by dx answer is 1 over 2t into dy by dt. Can you see? This one, dy by dx is 1 over 2t into dy by dt. Minus 15y equals 15x. So now it's a matter of opening brackets and getting to show that d square y by dt square. I think things will just cancel out and come nicely. Dy by dt Here, of course, the 2 and 2 will cancel. Can you see? And you can open the bracket with 1 over t dy by dt with these two guys, right? So 1 over t dy by dt into 1 is plus 1 over t dy by dt. Can you see? The next one, plus 2 root x into 1 over t dy by dt. Is that okay? Minus 15y equals 15x. I think we can see here that the problematic part cancels off, right? It cancels off. So now I think I'm closer to my show that d square y by dt square plus 2 root x. So actually we need to replace the x, right? Yeah, so t is t square x, which means t is root x. So t is root x here. I could replace 2 root x over this t is root x. Can you see? I'm replacing the denominator t here with root x. dy by dx minus 15y equals 15x. Once again, x is t squared. So here the root x would cancel off. So I end up getting d square y by dt square plus 2 dy by dy by dt, dy by dt here, isn't it? I have made an error, right? dy by dt here, isn't it? Is that the show that? Yeah, that's the show that. d square y by dt square plus 2 dy by dt minus 15y equals 15t square. Yeah. Okay, so this is the show that. So part B, solve the differential equation 2 to determine y in terms of t. Okay, so what do we do here? You can see here we have the differential equation in the normal format, right? So basically we have to first get the auxiliary equation by taking this as equal to 0, the homogeneous equation, right? So taking d square y by dt square, okay, we'll directly write, let's not waste time because I don't think we have time to do that. M square plus 2m minus 15 equals 0. You make it equal to 0 to get the complementary function, isn't it? Can I know the two roots here? 3 and minus 5. 3 and minus 5. Yeah. So m minus 3, m plus 3, m minus 3, m plus 5 equals 0. Basically, you get m is 3 or m is minus 5. So that gives you the complementary function y equal a e to the power. Is it 3x? Now see again the mistake you all are doing. You write here for out of practice you write a e minus 3x plus b e minus 5x plus 3x and minus. This is completely wrong. Because why? Our equation is this a dy by dx equation? Is it a d square? It's a dt equation, meaning the complementary function must not be in terms of x, it should be in terms of t. So do not make that mistake. If you do it, it's completely wrong. A e to the power 3t plus b e to the power minus 5t. Okay. So actually, even if you exchange these two guys and write a e to the power minus 5t and b e to the power 3t, that is completely fine. So you could exchange and write, there is no problem about it. Okay. Then let's move on to part C. We are not done. We have to find also, but this is just the complementary function. We also need to find the particular integral. This is 15t square. So your particular integral will be of what format? Y equals lambda plus mu t, not x, plus vx square, because the not x square. See, we are so used to writing it with x, right? So remember it's with t, lambda plus mu t plus vt square. Now let's differentiate dy by not dx, dy by dt, lambda goes mu plus 2v t. Adding part doesn't happen, right? You can see here your particular integral lambda mu t and vt square has it does not get together with these two, so you don't need to add an extra t here because you need to check those things as well, right? And even these two, if it looks like they can mix together and add the complementary function particular integral, we need to make sure we multiply it with a t so that it doesn't mix together, right? So mu plus 2vt and then d square y by dt square. This gives me mu is 0. This is 2v. So this is it. Now it's time to substitute these dy by dt and d square y by dt square and the y values into our main equation and actually find the values of lambda, mu and v. So let's get it done. D square y by dt square plus 2 dy by dt minus 15y equals 15t square. So I end up getting a d square y by dt square is 2v plus 2 dy by dt inside brackets mu plus 2vt minus 15 times y is lambda plus mu t plus vt square equals 15t square. Is that okay? So now what we do is don't go to open brackets. It's a huge waste of time. Let's just compare coefficients. So let's compare coefficients. First, let's start with the constant. No, let's start with the t square, right? Because when we start with t square, we get the first answer. Comparing coefficient. Comparing coefficients. So starting with t square coefficient, I can see here 2v, 2 mu, 4vt, that's no t square. The only t square I get is from here, which gives me what? Minus 15v. Minus 15v equals, on the other side I have 15t square, which means t square coefficient is 15. So v equals 15 divided by minus 15 is minus 1. Then next one is the t coefficient. Let's get the t coefficients. I get here 2v, there's no t coefficient. Here I get this one, right? 2 into 2v is 4v. Do you see 4v? And I get 15 into mu t here. So let's write the two t coefficients. I get here 4v, right? 2 into 2v is 4v. So make sure you open the bracket. Minus 15 mu. Okay, equals, on the other side, there's no t function, which means it's equal to 0. So v is minus 1. 4 into minus 1 is minus 4 minus 15 mu equals 0. 15 mu equals to minus 4, which means mu is minus 4 over 15. Is that okay? Mu is minus 4 over 15. Then last, let's compare the constant. So constant means the one without any t value. So basically I get here 2v directly, 2 into mu and minus 15 into lambda, isn't it? 2v plus 2 mu minus 15 lambda equals, other side there's no constant, 0. So 2 into v is 2 into minus 1. 2 times mu is minus 4 over 15. Minus 15 lambda equals 0. So 15 lambda equals, can I know what we get here? 2 into minus 1 plus, so minus 2. This is minus 8 over 15. 38 over minus, right? Minus 38 over 15. When you divide by 15, minus 38 over 225 equals to lambda. So this is what we get. So now it's time to input the values into the answer. So the general solution is equal to what? Complementary function plus the particular integral. Okay, let's input the values. Complementary function. So the general solution y equals, what did we write? A e to the power 3t, right? Plus b e to the power minus 5t plus we wrote lambda, right? So lambda is minus 38 over 225 plus lambda plus mu t minus 4 over 15t. So I'm actually inputting the values for the particular integral, right? Lambda plus mu t plus vr. Substitute the particular integral and complementary function together. Minus 4 over 15t, right? And minus mu, yeah, vt square, yeah, minus t square, v is 1. So this is it. This is the general solution for the for part B. Okay, so this is the general solution for part B. I simply added the particular integral and the substitute the lambda, mu and v here, and the complementary function. I added those two together to get my final answer. Okay. Hence, determine the general solution of differential equation 1. So basically, we just found the general solution of differential equation 2, right? So differential equation 2 is with y with respect to t. That's what we got. The general solution of differential equation 1 is where you have y with respect to x. So basically you need to replace all the t values. So t is root x, right? So we need to replace our t with root x and just give the answer. It's simply 1 mark. Replace the t with root x and we get the answer with respect to y and x. So answer for part C, y equals, replace a e to the power 3 root x plus b e to the power minus 5 root x minus 38 over 225 minus 4 over 15 root x minus root x square is simply x. This is it. This is the solution for differential equation 1 where you have y with respect to x. Okay, so this is it. Okay, question number 8. The curve C shown in figure 1 has polar equation r equal 1 plus sine theta. And can you see the limits they have given? The limits are given from minus pi over 2 to plus pi over 2. Basically, you can see, I think you all now know the equation of 1 plus sine theta is actually the cardioid shape, right? So they have taken only part of it, half of it. Okay, so we don't need any of that. Okay, they are saying the point P lies on C. This point, shall I make this bigger? The point P lies on C such that the tangent to the curve at C is perpendicular to the initial line. Use calculus to determine the polar coordinates of P. Okay, they want to use calculus to find the polar coordinates of P. Okay, let's get it done. Okay, how do we do this one? I want to get the coordinates of P. At P, the tangent drawn at P is perpendicular to the initial line. Okay, how do I do this? When it's perpendicular to the initial line, we set dx by d theta 0. Okay, so before we set dx by d theta, we must know what is x. So normally we write x is r cos theta. That is the equation. Y is r sin theta, x is r cos theta. So replace the r value. R is 1 plus sine theta. Am I correct? R is 1 plus sine theta into cos theta. Now let's differentiate and get dr by dx by d theta. So dx by d theta is what I need to set to 0, right? So let's find it first. Dx by d theta, you can see that there's a product here. So when one person differentiates, the other one weights. So 1 plus sine theta weights. When cos theta differentiates, what do we get? Minus. Please check. When cos differentiates, we get negative sign, right? When cos differentiates, we get negative sign. So make sure you put a into here. And then plus. Now the cos theta weights, and let's differentiate inside the bracket. One differentiation is 0. Sine differentiation is cos. Okay, so then we have our dx by d theta. Now what do we do? If the tangents are perpendicular, dx by d theta is equal to 0. So set it to 0 because tangents are perpendicular. I get here minus sine theta times 1 plus sine theta. And here I get cos into cos is directly cos square, right? So 0 equals minus sine square theta plus cos square theta. Is that okay? Sorry, minus sine theta. I have to open the bracket properly, right? Minus sine theta, minus sine into plus sine is minus sine square theta plus cos square theta. So you can see this equation, I have sine square and cos square. Now to solve this equation, I can't have all these types. It needs to be everything with sine or everything with cos. So how do I fix that? We can replace the cos square. 1 plus sine square plus cos square is 1, which means 1 minus, which means cos square theta is 1 minus sine square theta. So which helps us to okay, so this helps us to make it into a quadratic equation. Minus sine square gives me minus 2 sine square theta minus sine theta plus 1. Do you agree with me? So I'll take everything to the other side because I prefer to keep my quadratic square term positive. I end up getting 2 sine square theta plus sine theta minus 1. Is that okay? So what are the factors here? I think we get good factors, right? Can I know the two factors here in the calc? 2 sine theta minus 1 and sine theta plus 1. So this is basically factorizing. Okay, so I end up getting here sine theta equals half or sine theta equals minus 1. Okay, so let's solve sine theta equal half. Now, I think you can see this point P here. When you look at this, you can understand that this is actually what? It's an acute angle, right? This theta value is an acute angle. So do I need to go rounds, many rounds? No, sine inverse half gives us the answer we want, right? Sine inverse half is pi over 6. Do I need to go rounds and get any more extras? No. So even sine inverse minus 1, this is sine minus 1 is 270, 3 pi over 2, right? So we don't need those stuff because you can see it's out of range. My graph ends at pi over 2. So you need to have a good understanding about the sine graph. Sine graph reaches negative 1 at minus 3 pi over 2 and at minus pi over 2 and at minus pi over 2. So at minus pi over 2, I don't need this one. Okay, so theta becomes minus 1 at minus pi over 2 and 3 pi over 2. All of those values are outside the range. None of them are inside the range. So I don't need that. So the only answer I have is pi over 6. That's all I need. So use calculus to determine the polar coordinates. I have the theta value. I have to get the polar coordinate means not only the theta value but also the r value. So what's the r value? R equal 1 plus sine theta is pi over 6. Can I know the answer? 1 plus sine pi over 6 is half, right? Basically, r is 3 over 2. So what's the polar coordinate at P? P equal r comma theta, 3 over 2 comma pi over 6. So this is the polar coordinate of point P. Is that clear? Okay, shall we move on to part B? Okay, moving on to the next part. The tangent to the curve at the point Q, where theta equal pi over 2. Can you see point Q? Theta is pi over 2, right? They have said it's parallel to the initial line. At this point, the tangent that we draw is parallel to the initial line, okay? The tangent to curve at Q meets the tangent to curve at P at the point S. Can you see? As shown in figure 1. The finite region R shown shaded in figure 1 is bounded by the line segment QS, SP and the curve C. Okay, use algebraic integration to show that the area of R. Okay, so now you need to think, you guys need to think about this and like try to figure out how to get this particular area. How do we get it? What is the, how do we set the boundaries? So think about it for a moment. How do we get the area? Okay, so then to get this area, what we do here is, you can see that we already found this line here. This line was theta equal pi over 6, right? Okay, so what we do is, basically we could integrate the curve from pi over 6 to pi over 2. So that would give me, when I integrate my curve from pi over 6 to pi over 2, I get the area in between the two half lines, isn't it? So I get this area. I get this area, isn't it? Okay, so now, but this is not the area I want. I want the area, the shaded outside area. So basically what we do is, we use the curve equation first from pi over 6 to pi over 2 and get this yellow color region. And then what I do is, I am going to find the area of this trapezium. Can you see that we have a trapezium here? So I'm going to use the area of this trapezium, and from the trapezium area, I'm going to subtract the area between the two curves, pi over 6 and pi over 2. This would give me the outside shaded region. So this is the easiest way to do it. Or else some of you would say we could get the area of the entire rectangle and then subtract the triangle. We could get the area of the triangle and this shaded part and get the outside. So all of those methods are correct. So I will go with the trapezium and subtract the area in between the curve. Okay, so let's get it done. First things first, we need to get all these coordinates done. So how do I get the coordinate Q here? How do I get the coordinate Q here? Because I need this, I need to know the line here. So when I get the area of, let me get the area under the curve. So area of the curve is, the equation we use is half r square theta, right? That's the equation we use. I'm going to get this yellow color area first. And my limits are from pi over 6 to pi over 2. Those are my limits. Let's integrate and get the yellow color part first. So half r square, r is 1 plus sine theta. and it needs to be squared. So half integration of 1 plus sine square is 1 plus 2 sine theta plus sine square theta. So this integration happens from pi over 6 to pi over 2. Then I end up getting here half. Let's integrate. So before integrating, we need to get rid of the sine square. Sine square integration can only be done by using the double angle rule. We need to use the help of cos 2 theta double angle rule. Cos 2 theta is 1 minus 2 sine square theta. Sine square theta is 1 minus cos 2 theta divided by 2, right? Sine square theta is 1 minus cos 2 theta over 2. So let's input that here before integrating. 1 plus 2 sine theta. Sine square theta is, if I separate the 2, it's half minus half cos 2 theta. Do you agree with me? It's half minus half cos 2 theta. I separated the 2 here. Then before integrating, I think I can again add these two guys. So then let's simplify as much as possible before we integrate. So I am not done with the integration yet. 1 plus half is 3 over 2 plus 2 sine theta minus half cos 2 theta. So now we are ready to integrate. Let's integrate half. Integration of 3 over 2 is 3 over 2 theta. Sine theta integration is negative cos, right? Sine integration. Sine integration is negative cos. Minus here half into cos 2 theta integration is cos ax plus b. It's 1 over a or 1 over 2 sine 2 theta. Am I correct? The limits are from pi over 6 to pi over 2. Is this okay? So the integration of cos is positive sign, right? Positive 1 over 2 sine 2 theta. Okay, then we get here half. It's time to input the limits, right? So I get here 3 over 2. Theta is pi over 2 minus 2 times cos pi over 2 minus half into half is 1 over 4 sine 2 times pi over 2. So this is the first limit. Subtract from the second limit. 3 over 2 into pi over 6 minus 2 cos pi over 6 minus 1 over 4 sine 2 pi over 6. Okay, let's get the answers now. Simplify. We need to get the answers in exact form. Half times 3 pi over 4, right? The first one. Cos 90 is 0. Cos pi over 2 is 0, right? Sine 2 pi over 2 is also sine pi. Sine pi is also 0. So basically the first bracket only gives me 3 pi over 4. Then the second bracket is with a minus sign. I get here 3 pi over 3 and 6 I can cut, right? So 3 over 2 into pi over 6 gives me 3 times 1. This is 2. I get pi over 4 here. Minus 2 times cos pi over 6 is how much? Minus root 3, right? 2 times cos pi over 6 is root 3 over 2. Into this 2 is root 3. Sine pi over 3. 1 over 4 sine pi over 2 pi over 6 is pi over 3, right? Yes. 1 over 4 into sine pi over 3 is minus root 3 over 8. Root 3 over 2 into 1 over 4, root 3 over 8. Yeah, that's correct. And then close the big bracket. Okay, now let's open the bracket. So I get here half times 3 pi over 4. I'll open the bracket minus pi over 4 plus root 3 over 8. Let's simplify where we can. 3 pi over 4 minus pi over 4 we can simplify. What do I get? 3 pi minus 1 pi is 2 pi over 4, isn't it? 3 pi minus 1 pi, 2 pi over 4 is pi over 2. Plus root 3 over 8 we can add. It's similar terms, right? We can add these two guys. We are adding, not multiplying. Root 3 plus root 3 over 8 is 8 plus 1 is 9 root 3 over 8. These are just adding fractions. Okay, so this is the answer I get for what? The area that is shaded between pi over 6 and pi over 2, right? This is the answer that I get for the shaded area, the yellow color area. However, that is not the area that I want. Okay, so in this question, the area that I want is this outside part. So how do we get the outside part? Now I need to get the area of the trapezium. So how do I get the area of the trapezium? You will realize I need to find this limit. I need to get the length of this line. I have to get the length of QS, OQ. I need to get the length of this other one. All these lengths need to be found. So how do I get the OQ length? You can notice that Q is on the polar equation, right? So basically, I could input Q as pi over 2 because at Q, the theta value is pi over 2. So you could replace your theta as pi over 2 and get the R value. Right, so let's replace theta as pi over 2, r equal 1 plus sine pi over 2. I get the q distance. So 1 plus sine pi over 2 is 1, r is 2, right? It gives me this OQ distance is 2, the r distance. R means the distance from O to Q. Okay, so I get that. To get the trapezium, you realize I need the PS distance as well as the QS. I need all of them. So how do I get them? The next thing we do is we know the OP distance because OP R we found in the P coordinate R was 3 over 2 comma pi over 6. So this R distance is 3 over 2 and the theta value is pi over 6 here. So I can get this distance. Now one mistake people do here is they use theta as 0 in an attempt to get the length of this line. If you use theta as 0, you don't get the length of this full line. No, you end up getting this distance, the distance from the O to the place where theta is 0 in your polar equation. So that's not the length I want. I want this full length from until this point. So don't use theta as 0 in your polar equation because that gives you the not the length that we need. So basically what we do here is I have this angle as pi over 6. I know this polar equation at P. Basically I could get the x distance by using x is r cos theta. You could even say 3 over 2 cos pi over 6 also resolves to give you this distance, right? R cos theta, 3 over 2 cos pi over 6 is this distance. The y distance is y is r sin theta. Or you could see it literally here, 3 over 2 sin pi over 6 is the y distance. So now you can see that I have my x and y distances. So now I can get the area of the trapezium. Are you with me? I can now find the area of the trapezium. Let's find the area of the trapezium now. So area of trapezium is, first to get the area of trapezium, shall I find the PS and QS distances? So QS, of course, we found, right? QS is the x distance. 3 over 2 cos pi over 6 is how much? 3 root 3 over 4. Is that okay? Okay, then the next one, I need to get the PS distance. How do I get the PS distance? Because for the trapezium, I need this. Yeah, from the whole length OQ2, I should subtract 3 over 2 sine pi over 6. Can I know the answer? 5 over 4. So it's a matter of typing this in the calc. I have QS, PS distances now. Now it's the matter of getting the area of trapezium. So area of trapezium is half A plus B are the lengths of your parallel lines. What are the two parallel lines here? OQ and PS. Half the addition of the two parallel lines into perpendicular distance between two parallel lines is QS. So I end up getting here half. OQ is 2. PS is 5 over 4. QS is 3 root 3 over 4. Can you simplify this? Half 2 plus 5 over 4 is 8, 13 over 4, right? Final answer. Can I have the final answer in the cal directly? How much? Over 32, 39 root 3 over 32. It's a matter of typing it directly in the cal. Now what do? From the trapezium area, we subtract the area I found in between the two half lines. From 39 root 3 over to 32. So shaded area. Shaded area, I subtract from the area of the trapezium, 39. What was the answer for the trapezium? 39 root 3 over 32, right? From that, I subtract the area of my the area of the shaded part in between the two curves. So that is half. So this gives me 39 root 3 over 32 minus 5 over 4. Minus into plus is minus 9 root 3 over 16. So I could simplify these two. 39 root 3 over 32 minus 9 root 3 over 16 because they are like terms. Type them in the cal. 39 root 3 over 32 minus 9 root 16. If it gives a decimal, then just give 39 over 32 minus 9 over 16. The root 3 you could write it by yourself. How much? 20 over. You got exact answer in the cal with the root 3. Did you type? Yes. Okay. Then minus 5 over 4. Is that the show that they want? They have taken 1 over 32 out. So let's take 1 over 32 out. Taking a 1 over 32 out means this is 21 root 3. You should know you're taking a number down as a from the denominator. You are multiplying the numerator by 32. So 21 root 3 over 32 into 32. 32 cancels. Minus 5 over 4 into 32. How much is it? Because you're taking a 32 out. If you input the 32 back in, it would cancel, right? So I end up getting 1 over 32. 21 root 3 minus 8 pi. 21 over 32 minus 21 into 21 root 3 minus 8 pi. Yes. So this is the answer where A and B are integers to be determined. So this is the answer for the area question. Okay. Okay, question number 9. Show that. Okay, so it's just a 2-mark question for this. Show that n to the power 5 minus n minus 1 to the power 5 is equal to this. Okay. So I think the easiest way to get it done would actually be to what? To open the bracket, right? N minus 1 to the power 5. We can open it from binomial expansion. Okay, so let's get it done. Part A. N to the power 5. Let me open n minus 1 to the power 5 first. So I'm going to do it from this side. Okay, I'm going to open the n minus 1 to the power 5 manually. So it's going to give me 5C0. Then I get here, it's n minus 1, right? Can you see? So you get n to the power 0 minus 1 to the power 5. Next one, 5C1. N to the power 1 minus 1 to the power 4. Next one, 5C2, n to the power 2 minus 1 to the power 3. 5C3, n to the power 3 minus 1 to the power 4. Circle minus 1 to the power 2. Next one, 5C4, n to the power 4 minus 1 to the power 1. Last one is 5C5, n to the power 5 minus 1 to the power 0. Do you understand? We use the binomial expansion. Okay, then let's input the values. Quickly tell me what is 5C0 is 1. N to the power 0 is 1. Minus 1 to the power 5. When you have to a negative power, it's minus 1. So minus 1 to the power 5 is minus 1 here. So basically first term is 1 into 1 into minus 1. First term is minus 1. Next person 5C1 is 5 into n minus 1 to the power 4 is just 1. Next one 5C2 is 10 n to n square minus 1 to the power 3 is minus 1. Are you with me? Minus 2 odd power is negative. Minus 1 to a even power is positive. 5C3 is 10 n to the power 3 minus 1 to the power 2 is plus 1. Are you with me? Next one 5C4 is 5 into n to the power 4 minus 1 to the power 1 is minus 1. Last one 5C5 is 1. N to the power 5 is n to the power 5 minus 1 to the power 0. Any number to the power of 0 is 1. I hope you guys can see this is the first term. This is the second term. This is my third term. This is the fourth term. Isn't it? You can see it, right? This is the fifth term and this one is the last term. Okay, so I just gave the colors to show how it came. Okay, now it's simplifying. I get here minus 1 plus 5n minus 10n square plus 10n cube minus 5n to the power 4 plus n to the power 5. This is what I have for n minus 1 to the power 5, the expansion. Now what do I need to do? I have to take n to the power 5 minus of it, right? So let's subtract. The show that is to go to n to the power 5 minus n minus 1 to the power 5. So n to the power 5 minus this guy, right? Okay, are you with me? So now what's happening? When you open the bracket, I think you can see minus minus becomes plus. The plus n to the power 5 and here the minus and plus is becoming minus. Basically, the n to the power 5 will cancel off. Do you see it? I end up getting here 1 minus 5n plus 10n square minus 10n cube plus 5n to the power 4. Is that the show that? Plus 5n to the power 4 minus 10n cube? Yes. Yes, we get it. We get it the other way around. So just rearrange. It's the same thing. Okay, it's basically the same. So this is the answer for part A. Just 2 marks, but they're getting the expansion. You need to be able to get this right. Okay. Okay. Let's move on to part B. The method of differences, right? Hence, using the method of differences, show that for all integer values of n, the summation of r to the power 4. Okay, they're asking you to get this, show that. Okay, now look at this. How do we get the method of differences? Now, basically, you can see the method of differences can be used only for these two sections. Can you say you have n to the power 5 minus n minus 1 to the power 5? Method of differences can only be used here. Okay, so what I'll do here is, now I have here 5n to the power. I have written here the formulas that you need to do this particular question. We need the formulas in F1, the summation of 1 from 1 to n, summation of r from 1 to n, summation of r square, summation of r cube. These equations are taught in F1, the series chapter. So we need all these equations in to do this part B. So let's see how it's done. So part B, basically, I need to get the summation of r to the power 4, right? But you can see r to the power 4, I have n to the power 4 here. Can you see? So this is what I'm going to subtract. The n to the power 4 is what's going to give me this. Now, what I do here is, shall I replace this equation? Instead of n, we can rewrite the whole thing with r. Basically, it's the same thing, right? So if I write here 5r to the power 4 minus 10r to the power 3 plus 10r square minus 5r plus 1, it is equal to r to the power 5 minus r minus 1 to the power 5. Is that correct? Because I just rewrote this whole thing. So now what I'll do is, I'll take the summation of this equation from r equal 1 to n. Can you see? I'm going to take the summation of this equation from r equal 1 to n. So if I take the summation of the left side, I must take the summation of the right side. Are you guys with me? Okay, so then let's get the summation from r equal 1 to n. Okay, so that's what they want here. I mean, they want the summation of r from 1 to n only for the r to the power 4. Isn't it? Only for the r to the power 4 they want. So the other guys, I need to simplify and kind of solve it out. Okay, let me first get the method of differences here. So when r is 1, what do I get? I'm not going to put r equal 1 to this side. For this side, I'm going to use standard formulas. We'll come to that part later. Use r equal 1 here. What do I get? 1 to the power 5 minus 1 minus 1 is 0. 0 to the power 5. This is the first one. Then when r is 2, summation means we keep on adding, right? But in here the addition happens. We are adding it downwards, not sideways. Basically, I would put r equal 1 plus the r2 plus the r3. We write it sideways. But now, in method of difference, because people cut off, we write it downwards to see the cutting pattern. So when r is 2, what do we get? 2 to the power 5 minus 1 to the power 5. Next, when r is 3, I get 3 to the power 5 minus 2 to the power 5. Can you see the cutting pattern? Yes, I think we can see the cutting pattern quite clearly, right? So it cuts to this way. Can you see all of this cuts this way? Meaning, basically, I have only one term here. According to the cutting pattern, there will be 1. So I have 1 on the top right hand, which means I will have 1. According to this cutting pattern, I'll have 1 remaining on the bottom left hand. So then I need to write r n minus 1? No, right? Only one person remains. So basically writing r equal n is enough. So I have middle terms and I write r equals n, because we had to go from 1 to n. So n to the power 5 minus n minus 1 to the power 5. So basically, even this term would cancel out, right? So end of the day, the summation is the addition of all of this. Since all these middle parts cancel, you can see n to the power 5 and the minus 0 to the power 5, but basically it's 0. So the addition of this section is just n to the power 5. So that is the summation. So this n to the power 5 is equal to the summation of, I have to get the summation here, minus 10r cube plus 10r square minus 5r plus 1. This summation is equal to n to the power 5. Do you see it? Because I got the right side answer separately. So this answer, I continue this over here. Is that okay? I took this down over here. So now I have to find r to the power 4. I have to make r to the power 4 the subject. So let's input the, shall we input the summation mark separately for all these guys? So 5 times, so the constant you can take it out. So 5 times summation r to the power 4, here minus 10 times summation r to the power 3, here plus 10 times summation r square, here minus 5 times summation r plus summation 1 equals n to the power 5. Do you see? Okay, so then all these summation equations formulas were given. So we just need to apply to this side and make what? 5r to the power 4 the subject. That's all we need to do. So shall I keep 5r to the power 4 here and 5 summation r to the power 4, right? And shall I take the numbers to the other side? I get here n to the power 5 in this side plus 10 times summation r cube. I'm taking these guys to the other side. Minus 10 times summation r square minus plus 5 times summation r minus 1 times summation of 1. Okay, now can you all tell me the equations? I gave you the equations earlier. So have a look at it and tell me. N to the power 5, there's nothing to do here. 10 times summation r cube was 1 over 4 n square n plus 1 square, right? Okay, next one. Minus 10 times r square summation 1 over 6 n plus 1 2n plus 1. Next one, plus 5 times summation of r is n over 2 n plus 1. Last one, minus summation of 1 is just n. Just n. Okay, I had to get this show that. Okay, now I need to simplify this to get this show that. Okay, the show that has 1 over 30 n plus 1. Okay, we have a lot to simplify. So let's work on this. Okay, let's work on this. So 5 times summation r to the power 4. Basically what I could do is, let's try to take the common things out as much as possible. Like I can see everyone has an n in common. Can you see? So let me take the n out. Okay, let me take the n out. Then I remain with n to the power 4. 10 into 1 over 4 is 5 over 2. N square becomes a n, right? Because I'm taking n out from everyone. N square becomes n. N plus 1 square. 10 over 6 becomes minus 5 over 3. This n removes out because you're taking it out. N plus 1, 2n plus 1. Is that okay? This one is 5 over 2n, n plus 1. And the n is not there, yes. The n removes out, right? 5 over 2, n goes out, n plus 1, minus 1. Okay, so this is what I have. Now the thing is this, if you go to now I need to get the show that it's fully factorized. This is the show that was fully factorized. Now if I go to open the brackets, it's going to become like a huge disaster. So don't go to open the bracket. Can you suggest what's the next thing I should do? Because these brackets, we shouldn't go to open. It's going to be a bigger problem. What I can see here is the n to the power 4 and the minus 1. I can see the n to the power 4 and minus 1. And what should come into our mind when we see n to the power 4 minus 1? 1 to the power 4, difference of 2 squares, right? So n to the power n square minus 1 square. Basically difference of 2 squares. N square minus 1, n square plus 1. Are you with me? That gives me another n minus 1, n plus 1. The n square minus 1 can be further, we can further separate, right? N minus 1, n plus 1. Do you see it? Okay, then let's take that also out. Let's simplify it one more step. So I'll write here n times. Shall I directly write n to the power 4 minus 1 is n minus 1, n plus 1, n square plus 1. So this is the simplification of these two guys. Plus 5 over 2n, n plus 1 square minus 5 over 3, n plus 1, 2n plus 1. Am I correct? Plus 5 over 2, n plus 1. Okay, I did not leave any extra n's here, right? Okay, now, yeah, take as much as possible, and you can see in the show that n is there, n plus 1 is there, and there's a 30 also, right? Shall we take the 30 also out? The 30 out, if you're taking the 30 out, you're multiplying everyone by 30, because the show that, not a 30 actually, there's a 5 also here, ne? The 5 will come to the other side, because the summation r to the power 4 is subjected. Basically, 5 comes to the other side as a division. So to make 30, that means we need to take a 6, because you can see here 3 and 2. So obviously common denominator is 6. So basically I'm taking a 6 out from the denominator, means I'm multiplying all these guys by 6. Okay. So what I'll do in the next step is I'll write here 1 over 6. I'm taking 6 from the denominator. And the n is there, and I'm also taking a n plus 1. I'll take the 1 over 6 because n plus 1 is now common to everyone. Okay. So what's remaining now? Remember, you are multiplying. Taking a 6 out from the denominator means you are multiplying everyone by 6. Taking n plus 1 out from the numerator means you are dividing everyone by n plus 1. Okay, so this gives me 6 times n minus 1, n square plus 1. Is that okay? Plus 5 over 2 n, n plus 1. Is that okay? 5 over 2 n, n plus 1. Not 5 over 2. I need to multiply it with 6, right? 6 times, yeah, 6 times 5 over 2 is 15 n, n plus 1. 5 over 3 into 6 is minus 10, n plus 1 goes out, so 2n plus 1. 5 over 2 into 6 is 15. The n plus 1 goes out, right? This is okay. I took the n plus 1 out from everyone, right? N plus 1 gone. N plus 1 gone. 1. And here, yeah. Okay, now we need to further simplify. Okay, I'm almost there, but I still need to simplify this a lot, right? Okay, let's try to get it done. 1 over 6 n, n plus 1. Doesn't look like it's going to make it any easier for us, right? Okay, I think we need to get a 2 and the next factor they have taken out is a 2n plus 1. Can you see? The next factor they have taken out is 2n plus 1. Is it possible to create 2n plus 1? There's 2n plus 1 here. Okay, I think we'll need to open the bracket because we don't have any further way to simplify this, right? Yeah, we'll need to open the bracket. Shall we open the bracket now? Because this is the best we can do, taking out, in terms of taking out, this is the maximum I can take out at this point. Let's take, so let's open n cube, n into n square n cube, plus n minus n square minus 1. Are you guys okay with it? 15n square plus 15. Shall I keep the 10 times 2n plus 1 inside the bracket? Because basically, I'm trying to get like a 2n plus 1 out. Okay, because in the show that they have n plus 1 and 2n plus 1 also factorized and taken out. So if I could try to create that, but I think the n cube will not simplify with anyone, right? Or the n cube doesn't factorize with anyone. So then I think we don't have a choice here, right? Yeah, we will have to open the bracket here. That's because I can't get rid of the n cube. Let's try it. Let's try. 6n cube. Shall we add it all together? 6n minus 6n square minus 6. Any possibility where I could get things together? Minus 20n minus 10. Yeah, let's just get it together. 6n cube. Let's quickly add. N cube by added. Next one, 6n minus 6n square plus 15n square is plus 9n square. Next one, plus 6n minus 20n. How much? Minus 14n. The next one I have minus 6 plus 15. How much? Minus 6 plus, sorry, minus 6 plus 15 plus 15. Minus 6 plus 15 plus 15. 15 plus 50, 30. 30 minus 6 is 24, right? Minus 10. Minus 10 is also there, 14. Okay. Is there anything I can take out from this point? Anyone in common? No, right? 2 and 3, I can't take it out. Now, the thing is, I come to this cubic key equation. I end up getting the cubic key equation 6n cubed 9n square minus 14n plus 14. Now, when I look at the show that, do you see the show that now I have already got the n plus 1 out? Okay. Basically, can you see I have a 2n plus 1 here? Another factor has 2n plus 1, which means what? Which means this cubic key equation must be perfectly divisible by what? 2n plus 1, because this 2n plus, if I can take a 2n plus 1 out of this, 2n plus 1 should be, we should be capable of perfectly dividing 2n plus 1. So let's do a quick division. Yeah, because we need to divide and get it right. Let's see, because the show that has a 2n plus 1, we understand 2n plus 1 must be capable of dividing this, right? So start it. 6n cubed divided by 2n is 3n square. Long division. Multiply 3n square 2n is 6n cubed plus 3n square. Subtract. So this is 0. 9 minus 3 is 6n square. And you can bring the other guys minus 14n plus 14. Now 6n square, again you need to divide by 2n. 6n square when you divide by 2n is plus 3n. So plus 3n you should multiply with the 2n and plus 1. Plus 3n into 2n is 6n square. Plus 3n into plus 1 is plus 3n. Subtract the two guys. 6 minus 6 is 0. Minus 14 minus 3 is minus 17n. Ooh. 16, 17. Okay, wait, guys, I have done something wrong here. Let's check that first quickly. Yeah, so the mistake here is the 15n square plus 15n here, right? 15n square plus 15n is the error here. Let's quickly change that. So I think the n term and the constant term changes, right? The others don't change. 6n cubed, 6n minus 20n is, sorry. Yeah, the n square term doesn't change. Plus 6n minus 20n plus 15n. Now, how much? Plus just 10. And then the constant, minus 6 minus 20, minus 6 minus 10 plus 15 is minus 1, right? Yeah. Is that okay? Okay, then let's change this one. So there's just slight change happening here. 6n cubed plus 9n square plus n minus 1, right? The first part of the division doesn't change. So this is 6, this one doesn't change, right? Then this part is changing. Plus n minus 1, right? Okay, so let's subtract now. So when I subtract, yeah, this part also doesn't change. 6n minus 6n is 0. N minus plus 3n is minus 2n, and this part comes down as minus 1. Can you see? Now it comes perfectly, right? So now 2n divided by minus 2n is not 1. 2n divided by minus 2n is minus 1. So minus 1 into 2n is minus 2n. Minus 1 into plus 1 is minus 1. So when you subtract, it perfectly gives the 0, which means I have the factors now. Okay, I'm sorry about the mistake. Okay, let's continue. So 1 over 6n, n plus 1. So basically the 6n cubed 9n square plus n minus 1 is given by these two factors. Can you see this factorizes to give you 2n plus 1 times 3n square plus 3n minus 1. This is the 7-mark question. So this is the answer. Yeah, this is the summation r to the power 5 times summation r to the power 4, right? Yeah, so when I make it r to the power 4 here, I end up getting here summation r to the power 4. The 5 comes down 1 over 30 n plus 1, 2n plus 1, 3n square plus 3n minus 1. Yes, so basically this is the answer. And this is the end of the F2 October 2021 paper discussion. Okay.